The universe is so amazing and diverse. Countless stars are scattered across its expanses, and each and every one of them is uniquely mysterious and remarkable. Every day, dozens of new stars are detected, and the exoplanets orbiting them are just as unique. Still, while striving to discover other worlds, we should not neglect our own system. The only place in the universe with conditions favorable for the genesis and evolution of life as we know it. There are 8 planets in the solar system, as well as dozens of satellites and millions of minor celestial bodies which remain understudied even in spite of the long years of observations and research. And today, we invite you to take a little tour and see some of the most exciting ones. We will start out at the very heart of our system, in the devastating heat of its star, the Sun. Flying by Mercury, which is scorched by its relentless rays, we will pass by Venus, shrouded in layers of clouds. After that, we will take a break on our native planet, the Earth. A journey to the past will give us insights into how the looks of its earlier inhabitants changed, from prehistoric saurians to the much more dangerous and unforgiving creatures, humans. After that, we'll proceed to the mysterious and barren Mars, which will be followed by a visit to a tremendous area of cosmic chaos where the trajectories of millions of celestial objects intermingle. By following an elaborate route among them, we'll reach Jupiter and Saturn, as well as their mysterious satellites. At the end of our journey, we will get as far as the dark edge of our system, where sun rays and heat don't reach. Here we'll make acquaintance with the gloomy world of Pluto and its enigmatic satellite Charon. After looking at their barren plains, we'll move further on, beyond our system's boundaries, and try to catch up with the Voyagers, the space roamers that have been doggedly cruising towards the stars for the past half a century. Let's get ready, and we begin. Kosmo. The first in outer space. On the 21st of November 2021, the Parker Solar Probe was just 8.5 million kilometers away from the Sun. It was its closest approach ever to our star. This means that it was also the first probe that got to brush against the Sun's corona, the extremely hot outer layer of our parent star. But why was it necessary to go through a number of technical difficulties and approach the Sun that close? What is Parker after that it had to get that near the star, to areas where everything around turns into ash? To realize the purpose, we have to see what we already know about our system's star. To begin with, the Sun is a main sequence star whose age is approximately 4.6 billion years. It currently falls into spectral class G2V, which on balance makes it a typical yellow dwarf. The Sun's surface temperature is about 5,800 Kelvin, which is 5,530 degrees Celsius, but it should be mentioned that there are both colder and hotter areas to be found on it. Incidentally, the star's inner layers and its outer corona are as scorching hot as millions of degrees. But for all that, they barely contribute to the visible radiation. The Sun's average diameter equals around 1.4 million kilometers, which is 109 times that of our Earth. As for the star's mass, it reaches 2 times 10 to the power of 30 kilograms, or 333,000 times that of the Earth, and actually accounts for 99.9% of the mass of the entire solar system. We're used to seeing the Sun as small, but in fact it is larger and brighter than 80% of all the stars in our galaxy that we know of. Hydrogen accounts for 92% of the Sun's overall volume. In one of our previous videos on stellar evolution, we mentioned that it is mainly this gas that fuels thermonuclear reactions for the overwhelming majority of stars when its temperature reaches incredibly high values. As they merge, hydrogen nuclei release great amounts of energy and transform into helium, which gradually accumulates in the star's center. At the moment, helium accounts for 7% of the Sun's volume and 25% of its overall mass. In addition to helium, stellar matter contains other elements as well, like carbon, oxygen, nitrogen and iron, but their percentage is quite negligible. The Sun has an elaborate structure and is made up of several layers which differ in their properties. A massive core is at the center of the star. Estimates show its diameter to measure 25% of the Sun's overall size. The core's temperature measures as much as 14 million Kelvin, while 1 cubic meter of the material weighs around 150 tons. It is here that thermonuclear reactions, the source of energy for our star's luminosity, run their course. Every second, approximately 4.26 million tons of stellar matter is transformed into luminosity as a result of these processes. The core is surrounded by the so-called radiation zone, which continues to the point of 0.7 the Sun's radius. The density of matter in this area is too great for it to get mixed up thoroughly, and thus to carry heat to the upper layers of the star. That is why the way energy is transferred here is this. Particles of stellar plasma are continuously absorbing photons and radiating them again. Mathematical modeling shows that the temperature in this part of the star dramatically changes from 7 million Kelvin in its depth to 2 million Kelvin on the outer boundary. Estimates reveal that a quantum of light produced by the core may stay in the radiation zone from 10,000 to 170,000 years, and only then to move on to the next layer of the Sun. The one lying above, known as the convection zone, forms the Sun's outermost layer and is comparatively dense. Stellar matter here is more rarefied and changeable, which gives rise to enormous vortices in the convection zone. These vortices carry hot plasma from deeper regions of the layer to the star's surface, as it were, while plasma masses from the outermost areas, slightly cooled, move down. These convection cells remain stable for 10 to 15 minutes, after which they get destroyed to give rise to new vortices again. This continuous movement of matter creates a magnetic field, which pervades the entire inner part of the solar system. The Sun is also surrounded by an atmosphere. It is made up of several layers of elaborate structure. The lowest one is called photosphere. This area emits most of the star's visible light, so when watching the Sun, it is actually this photosphere that we see. As for its thickness, it measures from 100 to 400 kilometers, with a temperature fluctuating between 6600 and 4400 Kelvin, or between 6330 and 4130 degrees Celsius. Higher up lies a more rarefied area around 2000 kilometers thick, known as the chromosphere. It can be observed from the Earth at the time of a total solar eclipse, or else by employing special equipment. This area is extremely hot, with the temperature fluctuating between 4000 Kelvin and 20,000 Kelvin. Interestingly, its outer border is covered with spicules, continuously active jets of hot gas spurting up a staggering 5,000 to 10,000 kilometers high. The uppermost area of the Sun's atmosphere is called the corona. It consists of giant prominences, flares and emissions that may reach 1 million kilometers in size. The matter making up the corona is remarkably rarefied and incredibly hot, with an average temperature of 1 to 2 million Kelvin and the peak at 20 million Kelvin. It is this area that is occasionally crossed by the Parker probe, and every time the spacecraft immerses deeper and deeper into the blazing abyss. Calculations of the energy flow released by the photosphere will show it to be insufficient to heat the chromosphere and corona to such mind-boggling temperatures. This means that there are some physical phenomena concealed in the Sun that we have not yet discovered, which additionally heat up the upper layers. There are several scientific hypotheses that attempt to account for this thermal paradox. According to one of them, the chromosphere and the corona gain additional energy by dispersing magnetic shock waves. Another assumption explains it as an effect of charged particles' acceleration in the star's exceptionally powerful magnetic field. The Parker Solar Probe was specially designed in order to get to the bottom of these phenomena and to study obscure processes in the upper layers of the Sun's atmosphere. This probe is part of NASA's project known as Parker Solar Probe, launched back in 2009. 9 years later, on the 12th of August 2018, Parker took off from the surface of our planet on its one-way journey to the Sun to fulfill its mission. However, before getting that far, it had to execute a number of maneuvers to enter the desired orbit. By using Venus's gravity, Parker slowly adjusted its trajectory, drawing ever so closer to the scorching blazing ball in the center of our system. It was ready to withstand the star's searing heat. The probe had been designed with a heat shield, and all the equipment had been made with a view to extreme conditions to be faced. Besides, Parker's calculated orbit is supposed to lie in the Sun's immediate proximity for a comparatively short time, after which it pulls back and has a chance of giving out heat to space. This alleviates effects of thermal exposure. The probe's main task is to define the structure and dynamics of the magnetic fields in the Sun's immediate proximity. Also, Parker is supposed to gauge the energy flow emitted by the star, to capture particles of stellar wind, and to register wave-like processes in the Sun's corona. As a side mission, the probe took photos of Venus and the comet Neowise as it was drifting towards our parent star. To deal with the missions successfully, the probe is equipped with a wide range of scientific instruments like photo cameras, instruments for capturing particles, magnetometers, as well as radiation and radio wave detectors. A number of factors toward this mission. In addition to critical temperatures, the measuring instruments are exposed to an extremely powerful flow of ionizing radiation. The Sun creates strong interference in the microwave range around itself, which means that transmitting the data collected by the probe to the Earth is no easy matter either. Still, the Parker probe is carrying on with its mission. With every completed spiral of its orbit, the distance to the star shortens. In late February 2022, it is to pass through the Sun's corona yet again, in order to collect a new portion of data. By 2024, the distance between the probe and the surface of our star will shrink to become an all-time short, just 6.5 million kilometers. Estimates show that when the probe is in its perihelium, its solar shield may heat up to 1,370 degrees Celsius, which is 3 times hotter than Mercury's sunny side and only slightly lower than the melting point of iron. Even now, the probe is whizzing at a speed of 163 kilometers per second in its perihelium, but it will eventually accelerate to 200 kilometers per second, which will make it the swiftest man-made space object made so far. The probe's life expectancy cannot be that long. On reaching the closest possible point to the Sun, Parker will manage to complete several orbits around it, which is supposed to take roughly a year. All this time, it will keep losing speed, and the scientific instruments on board will be exposed to extreme temperatures and powerful radiation. Eventually, they will all be out of order, and the probe itself will descend into the scorching depths of the Sun to be totally swallowed up by a fathomless ocean of blazing plasma. But before it happens, Parker will beam great amounts of useful data back to the Earth, which will help us make yet another step in space exploration. This is a potent proof that Parker's flight will not have been wasted. Mercury lies relatively close to the Earth, but its exploration has always been associated with a lot of difficulties. On account of its close proximity to the Sun, it can be observed in the sky only at the very horizon, and this either shortly before sunrise or immediately after sunset. This is actually why ancient astronomers took Mercury for 2 different celestial bodies, which were given different names. Only the advancement of observation equipment enabled scientists to gradually reveal some of this unusual world's mysteries. The accumulated data shows Mercury to be the smallest planet in the solar system. Incidentally, it is even beaten by some satellites. Its radius measures 2,440 kilometers, which is roughly 38% that of the Earth. The celestial object is remarkable for its almost ideally round shape, as the difference between its equatorial and polar diameters is not over 1 kilometer. At the same time, given its modest size, Mercury has a surprisingly big mass. It equals 3.33 times 10 to the power of 23 kilograms, which is approximately 5.5% that of the Earth. Comparing Mercury's parameters with those of celestial objects close to it in terms of their size, Mercury is heavier than Ganymede and Titan put together, and that in spite of the fact that both of those objects' diameters are bigger. It is probably due to the fact that there's a massive metallic core with a radius reaching as much as 2,000 kilometers, accounting for about 57% of the planet's volume. The core is enveloped in a 400-kilometer layer of mantle made up of molten silicate rocks. The mantle, in its turn, is covered with a hard crust as thick as 15 to 37 kilometers. As for the planet's surface, it is vastly pockmarked with craters. Their analysis shows the celestial body not to have been noticeably geologically active for the past 3.8 billion years. Bright sunlight presents difficulties in observing Mercury through a telescope. However, this had been the only way of studying the planet until as recently as the second half of the 20th century. Everything changed in 1974, when the space probe Mariner 10 reached the planet's environs. It took pictures of 45% of the celestial body's surface, and also gauged its temperature and magnetic field. In addition to that, the probe's sensors registered the exceptionally rarefied atmosphere, made up of helium and other gases. 30 years later, on the 3rd of August 2004, another spacecraft took off the face of the Earth. Messenger. It took a long 11 years to reach its target, but the little probe did tackle all obstacles and eventually accomplished its mission. In the period from 2011 to 2015, Messenger beamed back hundreds of thousands of images for scientists to study, including pictures of Mercury's almost entire surface. Thanks to these pictures, important data was obtained on the celestial body's inner makeup, and various features of the planet's relief were detected, including unique ones in the solar system. Also, Messenger's sensors helped supply us with some knowledge about solar wind and its unusual interaction with the planet's magnetosphere. Mercury follows an elongated elliptical orbit around the Sun, which takes 88 days to complete. In its perihelium, the planet approaches the Sun as close as 0.31 astronomical units, with the distance in the aphelium 1.5 times as big, at 0.47 astronomical units. Mercury's orbital resonance, unique in the solar system, is of special interest. Its stellar day equals 58.65 Earth days, which is 2/3 of the Mercurian year. This makes the planet to face the Sun alternately, first with one side, then the other in the perihelium. These regions are exposed to solar radiation most, and are referred to as hot meridians. One of such regions boasts the largest geological formation on Mercury, designated on maps as Caloris Planitia. This name, which is translated as a heated plain, is fully justified, as the temperatures here reach 700 Kelvin or 427 degrees Celsius, making this area the hottest place on the planet. The plain is a gigantic impact crater measuring 1,550 kilometers and accounting for about 2% of Mercury's total area. Estimates show the crater to have formed approximately 3.9 billion years ago, after a collision of the planet with a large asteroid measuring as much as 100 meters in diameter. Mercury was a young and hot protoplanet at the time. The impact would have destroyed a great portion of crust that had barely solidified, and molten lava would have spilled over a vast area of the planet's surface. When it cooled and solidified, the plain was bound by a rocky crust, looking like a bright light spot easily noticeable against the dark valleys surrounding it. The surface of Caloris Planitia is pockmarked with a great number of craters measuring up to 100 kilometers in diameter. However, the most outstanding feature on this plain is Pantheon fossae. Unique in the solar system, this structure is formed by a radial set of 230 troughs or extension faults, with a width from 1 to 8 kilometers. Most of the troughs do not measure over 175 kilometers in length, with others running much further than that. There is a comparatively large crater, Apollodorus, lying not far from Pantheon Fossi's central point, but it is still not clear whether it has anything to do with the troughs. Today there are several hypotheses as to Pantheon Fossi's formation. According to one, the giant cracks appeared due to tectonic activity, while another deems the planet's cooling as the reason. Caloris Planitia is an area of flames and light. However, moving slightly to the north, we will find a land of ice and darkness. The tilt of Mercury's proper motion axis is very small, which is why its polar regions are perpetually enveloped in dusk. The sun here either hangs by the very horizon or does not appear in the sky at all. Its rays haven't touched the bottoms of some of the craters for as long as millions of years. There is no wonder that Borealis Planitia, a plain surrounding the planet's north pole, is the coldest region here. The temperature in some of its areas is around 80 Kelvin, which is 193 degrees Celsius below zero. Some deposits of water ice have been detected here in the shade of the mountain ridges around craters. Measuring up to 2 meters in thickness, they are covered by a layer of rocky dust, preventing the ice from evaporation. At the same time, some elevations, which do catch sun rays, may get as hot as 380 Kelvin, or 107 degrees Celsius. Interestingly, such contrasting areas of the surface may lie almost next to each other, but the planet's rarefied atmosphere does not allow them to effectively exchange heat, and so the stark temperature contrast remains. Our tour is getting us to more southern latitudes. Practically on one parallel with Caloris Planitia, but 3,500 kilometers to the west, there is one of the largest craters on Mercury, Rachmaninoff. Its diameter measures up to 290 kilometers, and it's roughly 1 billion years old. There is a tall peak ring in its center. It is formed by tall mountain peaks and measures roughly 130 kilometers in diameter. The rocks in this area are different from the rest of the landscape. They are of a reddish hue, and signs of solidified streams can be distinguished on the surface. This structure is assumed to be of volcanic origin and is a mark of one of the last volcanic activity events on the planet. Also, the lowest point on Mercury's relief has been registered here, which is minus 5,380 meters relative to the average value for the planet. Beyond the central ring, there are comparatively smooth and dark expanses. Moving on to the south, we will see a gigantic escarpment stretching for 820 kilometers from southwest to northeast. It is called Enterprise Rupees, which in some places towers as high as several thousand meters. There are quite a few escarpments on Mercury, but Enterprise Rupees is the largest. These bizarre features of terrain are believed to have formed as the planet cooled. When Mercury's interior gave away some of its heat, the celestial body slightly shrank, losing roughly 1% in volume. This deformed the planet's lithosphere, which produced gigantic folds. Almost half of Enterprise Rupees is located on the territory of Mercury's largest crater named Rembrandt. Its diameter measures 716 kilometers, and the wide basin contains a great number of smaller features of relief. For example, there are small mountain ridges running from the crater's outer ring to its center. Their width lies within 1 and 10 kilometers, and their length may reach 180 kilometers. Another ridge forms a ring roughly 450 kilometers in diameter. There is also an elaborate pattern of deep cracks to be seen on the crater's bottom, which resembles a spiderweb. It is believed that more detailed studies of the rocks forming the crater's surface should help us better understand Mercury's inner makeup and the processes running in its interior. In spite of close attention paid to Mercury by astronomers, and in spite of the advancement of observation equipment, the planet is still mysterious and largely understudied. However, even Mercury cannot stay unexplored forever. Even at this moment, the baby Colombo spacecraft is on its way, rapidly approaching this celestial body. It is a joint project of the ESA and Japan. The equipment on board the spacecraft will help collect data on the planet's surface and atmosphere composition, study the magnetosphere and solar wind, and update information on the relief features. Baby Colombo has passed Mercury before, but there are still a few elaborate maneuvers to perform up ahead to break speed and enter operational orbit around the planet. It is estimated that this will have happened by 2025, after which the spacecraft will go on to collect and transmit data. Venus is the Sun's second closest planet, lying 0.72 astronomical units away from the system's center. Its orbital period equals roughly 225 Earth days. Interestingly, every 584 days, the distance between Venus and our planet shrinks to its smallest at approximately 0.25 astronomical units. Notably, Venus faces the Earth with one and the same side throughout their closest approach. There is no hard evidence to account for this fact, but it may be either due to the tidal forces exerted by our planet, or else it could be a mere coincidence. In terms of its physical characteristics, Venus resembles the Earth in many ways. Its average radius equals 6,052 kilometers, or 95% that of the Earth, and its mass is 4.87 times 10 to the power of 24 kilograms, which is 0.82 that of our planet. Every 243 days, Venus completes a full rotation on its axis, and the rotation axis is tilted at 3.4 degrees with respect to the ecliptic plane. For a long time, Venus has concealed its real face from observers on the Earth behind a veil of its dense atmosphere and thick clouds. This gave rise to a whole plethora of highly imaginative hypotheses and assumptions. Some of them claimed that there was a highly advanced civilization concealed under the planet's impervious outer layer, while others suggested that there was a world that was home to peculiar life forms. Until a certain point in the recent past, assumptions about Venus were to be confined to the realms of fancy. Space flights and the advancement of radio location technologies proved to be a major breakthrough that made the desired answers closer than ever. For example, it turned out that radio waves of a certain range pass freely through the planet's atmosphere and get reflected from solid rocks. This effect made it possible to make the first maps of Venus back in 1978 by the orbiter Pioneer Venus 1. Soviet orbiters contributed to the collected data, but the maps were accurate up to 1 to 2 kilometers and outlined only the largest features of the Venusian terrain. This is the reason why it was necessary to go on to send the Magellan orbiter, a large specialized radar. In the period from 1990 to 1994, images of 95% of the planet's surface were beamed back to the Earth by the spacecraft. Interestingly, their resolution reached 120 meters. The information collected by the Magellan spacecraft is still considered the most exhaustive and accurate data about the Venusian surface. Before talking about any planet's surface, it's worth looking at its inner makeup. According to the most reliable and well-grounded theory, Venus has a metallic core at its center, whose mass accounts for as much as 25% of the planet's overall mass. Observations show that Venus has no magnetic field, which is why the metallic core is more likely than not in a solid state. It is embedded in a silicate mantle as deep as 3,000 kilometers. Its upper layer is a solid crust, whose average thickness measures as much as 16 kilometers. It is posited that Venus's lithosphere doesn't form tectonic plates on account of high temperatures and a high viscosity of the rocks. This makes the planet's geologic activity quite different from that on our Earth. Venus is also peculiar for not having that many large impact craters. Large areas of its surface are covered by basalt plains that formed from solidified lava. Some features of the relief found here are uniquely Venusian and are not to be found on any other planet in the solar system. An example of these is tesserae, highly ragged mountainous areas resembling roof tiles. Arachnoids and coronae are two other unique types of the planet's terrain. Round or oval structures with diameters measuring several hundred kilometers. They appear to be impact craters, but their origin is different. Rather than celestial objects in fall, they formed as a result of tectonic processes. An unprepared viewer will not easily notice any features of the Venusian terrain even in processed images. That's why let's take a look at the elevation map of the planet's surface, where areas of different height are marked by contrast colors. The region that instantly catches our eye is the largest elevated feature on Venus, nicknamed Aphrodite Terra. Areas like that may well be considered conditional continents of the planet. Aphrodite Terra is a gigantic territory stretching along the planet's equator. Its mountainous relief is rather elaborate. According to different estimates, the length of Aphrodite Terra may reach 18,000 kilometers and the width around 5,000 kilometers. Depending on the method of defining the continent's borders, its area is estimated in the range from 29 to 41 million square kilometers, which is comparable with the area of Asia. If we look at Aphrodite Terra, we will see three vast areas: Atla Regio, Thetis Regio and Dovda Regio. The first one of these is located in the eastern part of the continent and is notable for the highest volcano on Venus, Mare Mons. The distance from its foot to its peak measures around 5 kilometers, and the overall height above the average level of the celestial object's surface is anything from 8.3 to 8.8 kilometers, according to different estimates. The volcano is currently dormant, although there is evidence that it erupted comparatively recently in geological terms. Namely, it can be inferred both from solidified lava flows and lack of impact craters on the volcano's slopes. Dovda Regio sprawls in the western part of Aphrodite Terra. This is a region particularly attractive in terms of tectonic processes. The mountain ridges here run in different directions, which means that there are several forces tearing at the crust simultaneously and deforming it. Moreover, deep crevices have been discovered here that contain traces of lava spillage. These may well be considered the most bizarre volcanoes on the planet. We're moving on to the west, to the very edge of the continent, where the alleged descent points of 4 Venera probes can be found, and 2 of the probes were destroyed by the planet's atmosphere before reaching the surface. All these are located in the southern part of a vast lowland region known as Guinevere Planitia. It stretches for many thousands of kilometers and is quite a match to Aphrodite Terra in terms of area. Even though it is called a planitia, the area has an elaborate relief, which is a mixture of various geologic formations. It is thought that the planet's crust was being crumpled by tectonic forces for many hundreds of millions of years, and this produced the ridges and the folds. At the same time, the lava spilling from the crevices spread across and solidified, filling the lowlands with smooth basalt plains. As a result, this region is rich in both flat areas and clearly defined uplands. The western part of Guinevere Planitia borders on the so-called Beta Regio. As this vast area looks quite bright in photos, it is one of the first features of Venusian relief that got its own name. Beta Regio is an elevated area which is more or less round-shaped, with a diameter measuring roughly 2,500 kilometers. Its eastern part is the final abode of the debris of the spacecraft Venera 9 and Venera 10, the spacecraft which beamed back to us the first ever photos of Venus back in 1975. They also gauged the atmosphere's parameters and sampled the soil, which turned out to be similar to basalts back on the Earth. All this information allows us to assume that Beta Regio is the largest volcanic massif on Venus. That is why this area offers highest chances to discover active volcanoes on the planet. We're moving on to the north now, to the second largest conditional Venusian continent dubbed Ishtar Terra. It stretches for roughly 8,000 kilometers east to west and approximately 2,500 kilometers north to south. The territory's area equals about 8.5 million square kilometers, which makes Ishtar Terra only slightly larger than Australia. In the center is the largest volcanic massif on Venus, Maxwell Montes, They tower 11 kilometers high above the planet's average level and 7 kilometers above the rest of the relief around. The highest peak in the center of the region is a comparatively flat plateau, measuring roughly 200 by 400 kilometers. The difference in height doesn't exceed 1.5 kilometers, so it is extremely difficult to distinguish separate peaks, as the measurements are not accurate enough. Maxwell Montes are the coldest region on the planet. The temperature here is as low as around 380 degrees Celsius, and the atmosphere is about twice as rarefied as near the surface. Still, it is 44 times denser than that of the Earth. Another thing about this region is that it looks quite bright in photos, which means that the surface of the peaks and slopes is likely to be covered with some substance which reflects radio waves remarkably well. It is thought that it could be metallic compounds with impurities of sulfur like pyrite, hematite or galena. Exposed to high temperatures, these substances can vaporize from the surfaces of lowlands and then precipitate in colder mountainous regions as fine grain reminiscent of snow. While examining the Venusian surface, you can't help thinking this: are all these amazing and mysterious places to remain unexplored by humans? Is there a chance of us ever leaving our footprints on this planet's surface? So close, yet so forbidding. Because the atmospheric pressure on Venus is about 93 times that of the Earth, and the temperature near the planet's surface is on average 737 Kelvin or 464 degrees Celsius. These conditions are so extreme that even space probes specially designed to explore Venus last no more than an hour. As for terraforming Venus, this idea seems totally unrealistic. On the other hand, there are in Venus's atmosphere some layers whose temperature and pressure are close to those of the Earth. In the last century, ideas were even put forward about designing a habitable base, hovering in the planet's atmosphere suspended from special aerostats. Still, in reality, the actual possibility of putting such projects into practice remains an open question. And either way, Venus is awaiting her heroes, and her secrets will sooner or later be revealed. Approximately 252 million years ago, the Earth's biosphere suffered from a tremendous blow. Almost 96% of marine fauna, around 70% of land vertebrates, and roughly 83% of insects perished within a period really short by geological standards. The causes of this disaster are still obscure, but whatever it was, the dreadful calamity didn't wipe life off the face of the Earth. Quite on the contrary, it proved to be a milestone that marked the beginning of a new era. This is when there emerged the most well-known prehistoric creatures: dinosaurs. The Permian-Triassic extinction event marked the beginning of the Mesozoic, a new era in the geologic history of the Earth. It began approximately 252 million years ago and continued for around 186 million years. This was a time when our planet was actively transforming and gradually assuming its today's looks. The most crucial tectonic process of the epoch was the splitting of the single supercontinent Pangaea. First, it broke down into two landmasses, Laurasia and Gondwana, which in their turn went on to form the continents we know today. With several large, mutually independent territories separated by seas and straits, the conditions were perfect for independent ecosystems to emerge, which gave impetus to new evolutionary adaptations. In terms of climate, the Mesozoic was the warmest era in the entire history of multicellular life forms. Throughout this era, there was no ice shield even at the poles that would cover the ground for a long term. Still, temperature would drop from time to time, which forced both flora and fauna to adapt to the newly imposed conditions. The Mesozoic comprises 3 periods, and the first one is known as the Triassic. It began around 252 million years ago and continued for around 51 million years. This was the time when tectonic processes in the Earth's interior were just starting to break Pangaea into separate continents, and the supercontinent remained whole for most of the period. The Ural Ridge, one of the oldest mountain ridges existing to this day, completed its formation in the Triassic. At the time, the mountains were in their salad days and comparatively high. The period's climate was relatively dry and hot, which is why there were lots of deserts at the time and the area of inland bodies of water diminished. There was 10 to 15% of oxygen in the air for most of the Triassic, and then, around 215 million years ago, its level gave a sudden leap to reach as much as 19%. The reasons for this phenomenon haven't been established for certain, but it is assumed that it may have had something to do with the evolution and spreading of certain varieties of marine or land plants. Prehistoric seed ferns accounted for the overwhelming majority of the flora of the day, but later on they were gradually ousted by more progressive groups of plants. Those included cycas, ginkgo and prehistoric conifers. Many of these orders have survived to our day, although now they are not as diverse as they used to be. Marine life, meanwhile, was following its own course of evolution. The oceans, emptied by the Perm-Triassic extinction, were gradually populated by turtles and teleosts, and the first ichthyosaurus held the niche of large predators. Later on, they were to become reptiles best adapted to aquatic environment. But in the Triassic, these creatures were still rather primitive. An example of these is Symbospondylus, which lived 240 to 210 million years ago. This giant sea saurian measured 6 to 10 meters in length and ate mostly fish. This impressive creature had a long, thin body, half of which was a flexible tail. Its head was rather large, and the elongated sharp muzzle boasted a nice set of small and sharp teeth. Symbospondylus's limbs looked like diving fins, but it appears they were used only to stabilize body position in water. The saurian's skeleton structure suggests that it traveled through water by making wave-like movements, and generally speaking was rather clumsy. The most common representatives of land fauna of that time were Archosauria, prehistoric ancestors of dinosaurs, crocodilomorpha and birds, as well as other animal species. By the middle of the period, first dinosaurs evolved from ancient Archosauria as independent species, but there was still a long and hard struggle for survival up ahead for them. It was only by the end of the Triassic that dinosaurs started to establish their dominance in the Earth's biosphere, after sharply growing in size, which incidentally coincided with an increase of oxygen in the atmosphere. With dozens of films and thousands of books about horrifying saurians, anyone today would be familiar with what they looked like. At the same time, these giants seem to eclipse other species, which are by no means less important and interesting. For example, a Ligocyphus, a small creature that lived in the late Triassic around 200 million years ago. This small and deft little animal was a genus of cynodonts, prehistoric animals that differed from mammals in some not very clearly noticeable traits. A Ligocyphus had a thin flexible body measuring around 50 centimeters. It grew fur and generally looked like a weasel. Warm-blooded and herbivorous, it was widespread on the territories of today's North America, Europe and China. Even though it isn't known whether a Ligocyphus had a pouch on its stomach, the structure of its skeleton allows us to assume that its babies were quite small, which is typical of today's marsupials. It is also highly likely that a Ligocyphus fed its babies on milk. Another assumption about these creatures is that they dug burrows and made homes there. They also took great care about their babies, which may be evidence of a comparatively high intellect. Unfortunately, these creatures perished at the beginning of the Jurassic period, supposedly due to lack of food and heightened competition. Still, they remain the oldest prehistoric animals that look like today's mammals most. The Triassic-Jurassic mass extinction heralded the end of the Triassic period. A great number of amphibians, some Archosauria, other reptiles, as well as many plant orders vanished from the face of the Earth. Among the possible reasons for this disaster are volcanic activity, a change in the global ocean level, and sudden climate change. Either way, the extinction event vacated a number of ecological niches, which allowed dinosaurs to establish a firmer position on the evolutionary arena of the Earth. The next period of the Mesozoic was the Jurassic. It began about 201 million years ago and ended about 145 million years ago, which makes it roughly 56 million years long. This was a time of large-scale tectonic movements and reformations. It is in the Jurassic that the supercontinent Pangaea finally split to form several landmasses mutually separated by shallow seas. If we look at the map of the Earth at the end of the Jurassic period, we'll be able to distinguish the shapes of some of today's continents, although they would be positioned in unexpected places. Since the new continents were mutually independent, there emerged isolated biosystems. That is why some animals and plants that were abundant on one continent would be non-existent on another. The Earth's climate was warm and humid for most of the Jurassic period, and by its end a comparatively short cooling occurred. Great areas on land were covered with tropical forests, which were for the most part cycas, gymnosperms that resembled palm trees. Conifers were also widespread. Their looks were reminiscent of today's cypress trees and pine trees. On land, meanwhile, there started the epoch when dinosaurs positively flourished. Their diversity was rich, and they held most ecological niches while dominating almost every single one of them. Among these creatures, one could come across both small saurians the size of a cat and real giants. Herbivorous dinosaurs known as sauropoda came to be widespread in the Jurassic, with some typical representatives like Brachiosaurus, Brontosaurus, Diplodocus and others. They resembled each other very much. The largest one, Titanosaurus, measured as much as 25 to 30 meters in length and could weigh over 75 tons. An unusual feature typical of sauropoda is the so-called sacral brain, a widening in the hind part of the vertebrae that hypothetically could contain 20 times more nervous tissue than cranial brain. Today it is posited that the sacral cavity was likely to be filled with a glycogen body, which was a source of additional nutrition for the giant saurian's nervous system. Alongside dinosaurs, other animal species were evolving as well, such as mammals, reptiles and arthropods. The oceans were richly populated with bivalve mollusks, which in many ways resembled their today's descendants. The apex predators in the marine food chain were various saurians like Ichthyosaurus and Pliosaurus. Looking at Ophthalmosaurus, which lived at the beginning and the end of the Jurassic period, and comparing it with Symbospondylus, which lived earlier, it may be hard to believe that these animals are in fact related. Ancestor: Symbospondylus, lived 240 to 210 million years ago. Length: 6 to 10 meters. Elongated body and head. Badly adapted to aquatic environment. Descendant: Ophthalmosaurus, lived 165 to 145 million years ago. Length: up to 6 meters. Streamlined body, vertical tail. Well adapted to aquatic environment. This marine saurian had a dolphin-like body with an elegant and powerful crescent-shaped vertical tail. It is thought that the animal breathed atmospheric air and was able to stay around 20 minutes underwater, develop speeds of over 7 km per hour, and dive as deep as 600 meters. Judging by Ophthalmosaur's teeth structure, its diet consisted for the main part of mollusks, including squid. The animal's eyes were another distinctive feature in its appearance. Their diameter measured around 10 centimeters, and they were protected by a bony sclerotic ring. It is thought that Ophthalmosaurus could see well in the dark, which was a valuable asset for deep water hunt, and so the animal was free to dive far down where larger saurian predators couldn't get. The last period of the Mesozoic era is called the Cretaceous. It began 145 million years ago and lasted for around 79 million years, which makes it the longest one in the Mesozoic. The continents continued to break apart throughout the entire Cretaceous. India detached itself from Africa and slowly drifted in the direction of Asia across the Indian Ocean. South America broke away as well and made its way westwards. Eventually, by the end of the period, Africa, Australia, Greenland, North and South America assumed shapes close to those of today, while Europe and Asia were starting to get clearly defined borders. The climate in the Cretaceous was comparatively cool. In the period from 100 to 85 million years ago, the average temperature increased somewhat, and then cooling continued, which persisted till the very end of the era. This is exactly when Tyrannosaurus and Triceratops were around, the most widely known dinosaurs and truly distinctive symbols of the Mesozoic. Still, the period is much more notable for the spread of flowering plants, first trees and then grasses. They formed turf, and so strengthened the soils and made them more fertile, while nutritious seeds served as food for a wide variety of species. This gave evolutionary impetus to diversification of mammal species and also for some herbivorous dinosaurs, but on a smaller scale. Even though reptiles were dominating in all the ecological niches of that time, mammals continued to evolve. They grew to be more and more diverse, and by the end of the period, it was possible to single out separate groups, like ungulates, Eulipotyphla, predators and primates. Repenomamus, which lived around 125 million years ago, was one of the largest mammals of the Cretaceous. Its body measured up to 1 meter in length and it weighed 12 to 14 kilograms. This creature's appearance may have been similar to today's Tasmanian devils. Its teeth structure suggests that it was a predator, but its limbs were short and clumsy, so probably this animal was a scavenger. Incidentally, an interesting find was unearthed at archaeological diggings. It was Repenomamus's skeleton with bits of a small dinosaur in its abdominal area. This may serve as evidence that some mammals of the time could hunt small dinosaur species like Psittacosaurus and Dachyornithoides. Meanwhile, large aquatic saurians had long been dominating the seas: Ichthyosaurus, Plesiosaurus and Mosasaurus. However, around 95 million years ago, their population sharply dropped after the extinction event brought about by the second oceanic anoxic event, which had to do with a sharp decrease of oxygen in the ocean. One of the suggested possible reasons is increased underwater volcanic activity. The end of the Cretaceous was probably the coldest time in the Mesozoic. All living creatures set about adapting to the inexorably dropping temperatures, and dinosaurs were no exception. Around 70 million years ago, the territory of today's northern Alaska, above the Arctic Circle, was inhabited by a peculiar dinosaur species. This saurian is known as Nanuqsaurus. Remotely related to the horrifying giant Tyrannosaurus rex, this dinosaur admittedly resembled it, but its size was smaller. The body of Nanuqsaurus measured around 6 meters and it weighed just around 1,000 kilos. That is approximately 8–9 times less than Tyrannosaurus rex. This shrinking is thought to have had to do with a lack of available food in its habitats. Forced to survive in the dire conditions of the far north, among snowy stretches and in the semi-darkness of the polar night, this dinosaur developed some unusual features. First of all, it is likely that it was warm-blooded, and incidentally, the metabolic processes in its body ran their course remarkably fast, for example, as is the case with today's birds. Secondly, Nanuqsaurus's body was covered with several layers of down and feathers which allowed it to preserve warmth in the severe northern climate. This suggests that the northern saurian was probably an active and fast-moving predator, but in the conditions of the polar night, traditional ways of hunting prey are not that effective. That is why it appears that Nanuqsaurus had an exceptionally well-developed sense of smell and sensitive night vision. These assumptions are confirmed by the build of its cranium. Summer in northern latitudes was short and rather cool, so additional sources of warmth were needed for dinosaur eggs, so that the babies developed well. Nanuqsaurus is thought to hatch its eggs and to take great care about the young ones. Studies of fossil finds show that the volume of the brain of this species was rather big, Potentially, this dinosaur was as intelligent as most of today's birds. Unfortunately, these evolutionary adaptations didn't save Nanoxaurus from extinction. Around 66 million years ago, the Cretaceous-Paleogene extinction event caused all non-avian dinosaurs to vanish off the face of the Earth, alongside marine saurians, pterosaurs, and many other species. Still, the terrifying saurians left their imprint in the history of our planet, and the ecological niches vacated by them were promptly occupied by birds and mammals. This marked the beginning of the Cenozoic era. Its highest being was the unique creature that came to be known as Homo sapiens, the self-proclaimed king above all nature. Its evolution has only just started, and time will show what it has in store for this species. The Cretaceous-Paleogene mass extinction event heralded the beginning of a new geological era, the Cenozoic. Having started 66 million years ago, it is still going on. In the course of all this period, the Earth's surface underwent global transformations and offered its expanses to a great multitude of amazing creatures. The first period of the new era was dubbed the Paleogene. It started immediately after the disaster that wiped off dinosaurs and lasted for 43 million years. Our planet's appearance dramatically changed in this time. India crossed the ocean and virtually rammed into the south coast of Asia. The Himalayas rose their peaks up to the heavens, and the Antarctic began to grow its vast ice shield. In the first 10 million years, the Earth's biosphere was recovering from the fateful blow. With the old masters gone, agile and viable animals, mammals, quickly spread across the ecological niches vacated by them. Looking for new forms, life evolved and produced the duo Andrewsarchus, the giant and rigid Indricotherium, and the aquatic Archaeoceti, the prehistoric ancestors of today's whales. Many of these fascinating creatures vanished without a trace, while others evolved to adapt to the changeable conditions. About 23 million years ago, the Paleogene was succeeded by the Neogene, which lasted around 20 million years. It is divided into two unequal epochs, the longer one of which is called the Miocene. This was a time of unhurried and consistent cooling. Ice caps on the Earth gradually grew while the climate became cooler and drier. The global sea level was falling, and mountain ridges like the Alps and the Andes, on the contrary, were rising higher. As a result of this process, the Mediterranean Sea was cut off from the global ocean and almost dried up. In its place, there remained vast lowlands covered by a salty desert. According to some estimates, temperature in some of its areas reached 80 degrees Celsius, while the atmospheric pressure at the bottom of this basin was over 1.5 times the value of what we're used to. Just a few small lakes with extremely salty water were scattered across the bleak, lifeless desert. In that epoch, the vast expanses of our planet were home to a great number of bizarre creatures. Gigantopithecus, an enormous man-like ape related to orangutans, over 3 meters in height and with a body mass of up to half a ton, forced its way through dense Asian rainforests. Entelodon, an ungulate predator and scavenger the size of a bull, terrified steppe dwellers. As for the ocean, its depths were dominated by Megalodon, the largest carnivorous shark in the history of the Earth. Slightly over 5 million years ago, the area which is now known as Gibraltar was stunned by a tremendous earthquake. The rocky dam that had separated the Mediterranean Sea from the Atlantic Ocean for hundreds of thousands of years finally gave way, and millions of tons of water gushed into the gigantic lifeless lowlands. According to estimates, the force of the flow was 40,000 times that of the Niagara Falls, and it took only 2 years for the sea to fill up again. At the same time, thousands of tons of salt were buried under layers of sand and rock of remarkable thickness, and that's where it remains to this day. This tremendous event, dubbed the Zanclean Flood, is considered to be the beginning of the Pliocene epoch that was to last for 2,745,000 years. By that time, the continents had drifted to stay in the places we're used to seeing them, but some relief features were just starting to form. For example, North and South America was still separated by a wide strait at the beginning of the epoch, and the Rocky Mountains were just starting to grow. The Earth's climate in the first half of the Pliocene was comparatively warm. Our planet's average temperature was 2 to 3 degrees higher than it is now, although these extra degrees were not distributed across the planet evenly. The climate in the tropical latitudes resembled that of today, but northern areas were much warmer. The Arctic was not covered in ice permanently, and dense conifer forests reached the northernmost areas of Eurasia. Still, it should be borne in mind that the continent's border used to lie slightly more to the south than it does now, because the sea level at the time was on average 25 meters higher than today, on account of the higher temperature. Meanwhile, today's humans' first ancestors inhabited the African continent: Ardipithecus, Sahelanthropus, and Ororin. The unearthed remains of these ancient primates date 4 to 6 million years back. Their body build is still very far from that of humans. There is no doubt that these creatures were advanced apes rather than humans, but still they had taken the first step in evolution of a new life. Features of their discovered skeletons reveal a tendency to developing an upright posture, even though tree-climbing habits manifested themselves very clearly still. As for these creatures' cranial capacity, it was bigger than that of chimpanzees, and the teeth structure was similar to that of later species. What was it that forced the ancient primates to change so much? A possible reason could be that approximately 3 million years ago, the continental plains of North and South America collided and caused a rapid rise of rocks. The strait between the two continents was cut off by the Isthmus of Panama, which blocked the passage of warm ocean waters. At around the same time, the Rocky Mountains considerably gained in height, thus forming a barrier between the Atlantic and the Pacific air currents. With all these factors combined, the Earth gradually cooled and some parts of it grew to be icebound. The North Pole was gripped with an ice shield. Greenland started to build up tons of ice cap, while the areas of African forests shrank, giving way to steppes and savannas. Treetops make great habitats. They're safe and comfortable and provide one with plenty of food. This is what ancient primates agreed on. They adapted to the tree-climbing lifestyle extremely well. However, the global climate change eliminated the greater part of the African forests. Thousands of species lost the habitats they were used to, and so many of them vanished off the face of the Earth. Others were forced to adapt to survive in the new conditions. Today, the savanna concept is the most developed and well-grounded hypothesis of anthropogenesis. According to this concept, the deficit of their usual food and lack of woods forced our ancestors out into the savanna, riddled with unknown dangers. By this time, they were already capable of moving around on 2 legs and using primitive tools, just like all man-like apes. These skills were vital for survival in the new conditions. Easily digestible fruit and plants were sparse in the savanna, and rough grass and leaves were inedible for the primates. Tapping into animal sources of food became key to survival. However, one is supposed to be fast and strong to hunt successfully, and this is what our ancestors lacked. Only developing an upright posture could give them the necessary edge in these circumstances. Upright walking not only increased the speed of movement, but also allowed sighting both potential game and danger from far off. When the body is in the vertical position, strong hands with prehensile fingers are free, so a stick or a sharpened stone can be used much easier. By forming small tribes, the new inhabitants of the savanna could hunt, or at the very least take the kill of other predators away from them by force. It is assumed that the necessity to coordinate actions in the process stimulated the development of the brain and primitive speech. Gradual evolution in the course of several million years endowed the ape-like Ardipithecus and Sahelanthropus with human features. That's how Australopithecus came to be. This agile, smart, but not very big creature appeared on the territory of Africa in the period from 4.2 to 1.8 million years ago. Analysis of their fossilized remains revealed them to have been 120 to 140 centimeters in height and to have weighed around 40 kilograms. Unlike other primates, Australopithecus moved around primarily on two legs, although its posture remained stooped. As for its brain, even though it was larger than that of human-like apes, the differences in its inner makeup were minuscule. It is known that Australopiths lived in tribes and could cooperate for hunting and fighting enemies. Research shows that early species used only objects close at hand, while later ones learned to make the most basic and primitive tools to work and defend themselves with. In spite of all that, most individuals didn't live to be older than 20 because of illnesses, injuries, and wild animals' attacks. Apparently, the predators of that time saw Australopiths exclusively as a food source. Back then, Dinophilis was around, a large saber-toothed cat distantly related to Smilodentini, which were to emerge later. Diggings reveal that it preferred living not far from Australopiths' camps. It clearly saw them as easy prey. Slightly larger than today's leopards, Dinophilis was more thick-set and more powerfully built. With their weight reaching 120 kilograms, these predators were around 70 centimeters tall. It is next to impossible to fight this kind of animal single-handed, and probably the beast could be driven away by our ancestors only by joint effort. Of course, Dinophilis hunted not only Australopiths. Antelopes or wild boars, for example, were also part of its diet. Most animals inhabiting the Earth of that time resemble today's species. However, there were some real monsters among them too. For example, in North and South America, there lived several species of flightless predatory birds of the Phorusrhacidae family, whose largest individuals reached 3 meters in height. Their skulls measured as much as 75 centimeters, with a powerful beak accounting for most of it. Thanks to their rangier legs, the birds were able to develop great speeds. Fortunately, mankind didn't have to face these monsters, as the Phorusrhacids died out completely around 100,000 years ago, much earlier than America's first ancient tribes had settled there. The Asian jungles, meanwhile, were home to another giant, an elephant-like beast Dinotherium, whose mass reached 14 tons and whose height measured 3.5 to 4.5 meters. Of all land mammals ever to tread the surface of our planet, only Indricotherium and mammoths were larger. These distant relatives of elephants are thought to have inhabited the forests of Asia and Africa, subsisting mainly on tree foliage. Their trunks were probably shorter and thicker than those of the elephant, and the most outstanding feature in their appearance is their long, massive tusks protruding from the mandible. 2,588,000 years ago, a tremendous event occurred which got the name of the Gauss-Matiyama reversal. The Earth's magnetic poles swapped places, and all the magnetic lines changed their directions. The transformation was accompanied by a weakening of the planet's magnetic field, which decreased by 4 times. This means that cosmic rays, lethal to all living things, could now reach the Earth's surface. And even though this phenomenon was around for just approximately 15,000 years, which is negligible by geological standards, it caused several species to massively die out. This magnetic reversal is seen as a milestone marking the beginning of a new geological period, the Quaternary. It is divided into 2 epochs, the first of which is called the Pleistocene. It started 2,588,000 years ago and finished just 12,000 years ago. Periodic cooling accompanied by the growth of ice caps was typical for the climate of that time. In between ice ages, temperatures grew and ice caps melted, which made the sea level to rise. These frequent fluctuations in the climate forced living things to adapt to these changes quickly and stimulated the process of evolution. Gradually evolving, Australopiths gave rise to two large branches of primates: Paranthropus, an extinct genus today, and Homo, among others represented by today's humans. However, the three branches coexisted for a considerably long time in the competitive conditions of a struggle for survival. The evolutionary way from higher primates to humans was not straight and clear-cut. There were plenty of dead ends and forks. At least 24 different species roamed our planet at different times, whose representatives could be referred to as humans to this or that degree. The evolutionary process of humans and our ancestors is always paid a lot of attention to, and details are constantly being updated. It should be borne in mind that evolution is a very slow process. At least 2 to 3 million years is needed for species to completely part their ways and interbreed to give rise to viable hybrids. Meanwhile, the entire history of the Homo, the genus including today's human species, amounts to around 2.5 million years. With our most ancient ancestors taken into account, this figure can be pretty much doubled. Also, many populations inhabited neighboring areas, which means that there were probably quite a lot of hybrids out there in the natural world. It should also be borne in mind that interspecies variation in humans is quite high. There are noticeable differences between men and women, and people of different races also demonstrate clearly diverse features. It is thought that ancient species divided into races as well, some of which may erroneously have been classified as separate species by scientists. New archaeological finds help to correct these errors and supply important details to our knowledge. In spite of all their progressive features, Australopiths were apes to a greater degree than they were humans. The first universally recognized representative of the human species was the so-called Homo habilis, or handyman. Diggings show that handyman lived on the territory of Africa in the period from 2.3 to 1.5 million years ago. It had a more developed brain than Australopithecus and was able to make primitive labor tools. The height of this species' individuals was around 1.2 meters, with a mass likely to be 50 kilos or less. Interestingly, it was the first creature whose big toe was located in one row with the other toes, as is the case with today's humans. This could be seen as evidence of complete adaptation to an upright posture. Another important parameter was the structure of the jaws, which could indicate a gradually developing ability to produce articulate speech. Later, evolution produced Homo ergaster, or working man, about 2 million years ago, and Homo erectus, or upright man. Different scientists classify them either as close evolutionary branches or as subspecies of one species. In the course of migrations, these representatives of the human race settled on the territories of Africa, Asia and Europe, which stimulated numerous evolutionary branches. One of them eventually produced Homo sapiens. Ancient people, whether Neanderthals or Homo sapiens, lived in tribes and practiced a nomadic lifestyle. Living by gathering and hunting, they were forced to constantly migrate and move to new unexplored areas. In this manner, primitive tribes gradually settled all over the continents except the Antarctica. Around 50,000 years ago, exploration of Australia began, and about 24,000 years ago, people reached North America for the first time via the Bering Isthmus. The spread of primitive tribes across the globe coincided with mass extinctions of the megafauna in the Pleistocene. In the period from 50,000 to 10,000 years ago, mammoths and giant sloth Megatherium vanished off the face of the planet, followed by saber-toothed cats and other predators who were unable to keep up the fierce competition for food. Perhaps humans would have met the same fate, but around 12,000 years ago an ice age came to its end and our planet's climate became warmer and more humid. The fertile valleys of Mesopotamia and the Nile's estuary allowed our ancestors to lead a non-migratory gathering lifestyle, and later to form fully fledged agricultural communities after the so-called Neolithic Revolution. That was the end of the Pleistocene. which heralded a new epoch in the history of our planet. The Holocene was a time of robust growth of the human civilization, technical and social progress, destructive wars and ecological disasters. By choosing a unique path of evolution, man made first steps on completely new and unexplored territories beyond our planet. Only time will show what this path will lead to. Mars lies approximately 1.5 times as far from the Sun as the Earth. In contrast to our planet, its radius is twice as small. Its mass is around 10.7% that of the Earth, and the freefall acceleration on the surface is almost 3 times as little. The temperature fluctuates between 153 degrees Celsius below zero at the poles and 35 degrees Celsius above zero at the equator. The area of Mars's surface is roughly the same as that of all our continents combined. Its terrain is extremely diverse, with some geological features reminiscent of those of our planet and others quite unique and peculiar. The surface of Mars is currently closely observed from the planet's orbit by 8 automatic space probes. The data collected by them reveals that there is a vast light spot in the planet's western hemisphere. This region is the largest volcano in the solar system, and it is known as Olympus Mons. Today, this is the starting point of our tour around the Red Planet. Olympus Mons towers as high as 26 kilometers over the plains surrounding it. This is roughly 2.5 times the height of Mount Everest. It is assumed to be a shield volcano formed with multiple sheets of solidified lava. According to today's assumptions about the planet's inner makeup, there are no tectonic plates under the surface, which is why magma's eruption point can remain in the same spot for a long time, for hundreds of millions and even billions of years. That accounts for the fact why ejected lava spills out to cover incredibly vast areas, with a layer that subsequently turns into a rocky shield. The average diameter of Olympus Mons measures around 600 kilometers, and its area is over 300,000 square kilometers. These figures are comparable with the area of an average-sized European country like Poland or Italy. A giant depression formed with 6 calderas or collapsed volcanic craters is located in the center of the volcano. The diameter of the depression measures around 85 kilometers, and its depth reaches as far down as 3 kilometers. Olympus Mons is so high that the atmospheric pressure at the top is 50 times lower than at the foot. Since the atmosphere on Mars is about 160 times more rarefied than that of the Earth, the conditions on top of the volcano are slightly short of those in the vacuum. That is why the Red Planet's highest mountain cannot expect any visitor probes. The atmospheric density would be too low for parachutes to slow down a descending capsule with a Mars rover inside. With the average slope of Olympus Mons quite small, at only 5%, the volcano's edges and enormous sheer abysses of up to 7 kilometers high, it still hasn't been established for certain how such enormous slopes came to form. According to some assumptions, it was done by an ancient ocean on Mars. Other hypotheses hold sandstorms accountable, which continuously rage in this area. When we climb down from Olympus Mons and fly over its surroundings, we can see that there are lots of overlapping ridges and isolated mountains. Some of these formations stretch as far as 1,000 kilometers from the volcano's edge. It is assumed that they may have formed as the giant mountain slopes were eroding, or else due to movements of ancient ice caps. Whizzing on southeast from Olympus Mons, we will find ourselves in a vast region known as Tharsis. This volcanic upland, formed by solidified streams of lava, covers roughly 1/4 of the entire planet's surface. Its area of around 30 million square kilometers is comparable with that of Africa. Interestingly, the upland is 10 kilometers higher than the plains surrounding it, and its age could be about 3.7 billion years. There are a great number of volcanoes here, some of which only slightly smaller than Olympus Mons. Arsia Mons, for example, rises as high up as 19 kilometers, which makes it the second highest peak on Mars. With a summit caldera measuring 110 kilometers, the overall diameter of the mountain is over 400 kilometers. A unique natural phenomenon can be observed over the volcano every year for a short time. As sun rays warm the mountain's slopes, small dust spirals into a dense cloud, helped along by air streams going upward. This cloud may float up to 30 kilometers above our Sea Mons and may be scattered by winds across vast areas. Vertical pits can be seen in different places all over the upland. They are quite deep, with the bottoms quite unobservable. The diameter of the largest one measures around 150 meters, and its depth cannot be less than 178 meters. These pits are thought to be collapsed lava tubes. Tharsis is made up of dozens of overlapping shield volcanoes. In the billions of years of their eruptions, great amounts of CO2 and water vapor were released into the Martian atmosphere. Mathematical modeling shows that the amount would be enough to shroud the planet with an atmosphere 1.5 times as dense as that of the Earth. These estimates are in direct evidence of the fact that in the past, conditions on Mars may have been more favorable for life to originate there than now. With its gravity comparatively weak, however, the planet failed to retain its atmosphere and was eventually stripped of it. Moving on to the east from the plateau, we will get to the region known as Valles Marineris. It is a network of gargantuan canyons stretching for up to 4,500 kilometers. The width of the canyon reaches 600 kilometers and it's more than 11 kilometers deep. Images reveal that the slopes of most of the canyons in the central and western parts of Valles Marineris have a stratified structure typical of deposits at the bottom of a large body of water. It is quite likely that the canyons used to be completely submerged underwater in the distant past. There are some truly invaluable paleontological finds to be extracted from the rock deposits in this region. The eastern part of the valleys are areas with a rather chaotic relief. There are vast labyrinths made up of comparatively small canyons, abysses, mountains and plateaus. Further north, the terrain evens out into a relatively smooth plain known as Planitia. Its vast areas became the final resting place for the debris of the Sojourner Mars rover and also for the Viking 1 probe, which sent the first color images of Martian landscapes to the Earth as far back as in 1976. According to the widely accepted hypothesis today, Valles Marineris came to be in the early stages of the planet's formation. Erosion and geological processes were to deepen and widen the canyons later on. One version has it that the systems of chasmatas is thought to have formed after volcanic eruptions on the Tharsis upland. Another version claims Utopia Planitia to be the cause for their formation, which lies on the other side of the planet. This vast round lowland is likely to be an impact crater from an extremely large asteroid that would have hit the planet's surface. The Planitia's diameter measures some 3,300 kilometers. The terrain of the surface itself is rather flat and smooth. There were several attempts to explore Utopia Planitia by different space probes. In 1979, the Viking 2 lander beamed back panoramic images of its surface to the Earth. In 2016, the Charade radar on the MRO probe located rich deposits of water ice mixed with dust underground. In May 2021, the Chinese rover Zhurong touched down on Utopia Planitia. It has covered over 1,000 meters of the red planet's surface by now and has beamed back hundreds of images. Unfortunately, it cannot dig as far down as the water-carrying layer, with the latter as deep as 1 to 10 meters down. In the north, Utopia Planitia borders on Vestitus Borealis, a giant lowland surrounding the northern part of the planet and covering about 40% of its total area. Moving southwest from the center of Utopia Planitia, we will reach Isidis Planitia. The region on its western edge has been the focus of people's special attention for almost 8 months now. Of course, it is all about the Jezero crater. It is likely that millions of years ago there used to be a body of water here that has dried up by now. The Perseverance Mars rover and Ingenuity, the first ever helicopter flown beyond the Earth, have been exploring the bottom of the crater since the 18th of February 2021. The Jezero crater was chosen for the mission because it appeared one of the most promising places to discover traces of Martian life. The crater is posited to have formed around 4 billion years ago after a massive celestial body fell on Mars. The impact crater measured some 49 kilometers. As I've already mentioned, it is thought that it used to be filled with water, and the Hesperian of the geological history of Mars is singled out as the most likely period for that. The Hesperian started some 3.5 billion years ago and continued for around 1 billion years. Atmospheric pressure on the planet at the time is estimated to have been comparable with that on the Earth, with the surface temperature reaching 50 degrees Celsius. Rock samples recently extracted from the crater's bottom by the Perseverance rover are hard evidence of that. They still have to be transported to the Earth for deeper analysis, but it is clear even now that at some point the rocks have continuously been in close contact with liquid water. Perseverance has already delighted scientists with great amounts of useful data, and the mission is still far from being completed. The probe is designed for 14 years of operation, which means that there are still hundreds of finds to extract and kilometers of Martian terrain to cover. That is why our tour around Martian expanses is not yet over. Of course, we'll be talking about the main asteroid belt, one of the most changeable and mysterious areas in the solar system. Today, over 300,000 small celestial bodies found here have been given names and numerical designations. Interestingly, their overall number may well reach over 1 million. The starting point of studying the asteroid belt may be defined at 1801, when astronomers spotted a mysterious object in the sky after a long and hard search for the fifth planet. In terms of its parameters, it appeared to be a planet, but happened to be so small that even the most advanced telescopes of the day couldn't distinguish its disk. The researchers saw the newly discovered object as a bright dot like a star. It was dubbed Ceres, and very soon similar celestial objects of this class were discovered. A new term had to be introduced to refer to them. These unusual astronomical bodies came to be called asteroids, which literally means star-like. Apart from asteroids, this area in the solar system contains great amounts of cosmic dust. While slowly spiraling up, its tiny particles scatter sun rays and create a very faint white glow. This glow is referred to as zodiacal light. Interestingly, in equatorial areas of the Earth, it can be seen with the naked eye. For a long time, the following hypothesis used to be widely accepted. Asteroid belt objects were thought to be debris of a destroyed planet. However, today this assumption doesn't really hold water. First of all, the mass total of all the objects of the main asteroid belt is too small and equals just 3 times 10 to the power of 21 kilograms, or 4% the mass of the Moon. Even allowing for the fact that the greater part of asteroids would have left the belt a while ago, the total mass of the rocky debris still falls short of making up an object with dimensions comparable to those of a proper planet. Secondly, estimates show that large celestial objects cannot form in this area of the solar system on account of Jupiter's gravitational influence. Mathematical modeling revealed that the largest formations in the asteroid belt have never measured over 1,000 kilometers in diameter. The gravitational influence of their mighty giant neighbor rendered their orbits highly unstable, which made potential protoplanets collide and disintegrate into smaller bits. Traces of these collisions can still be observed. Most objects of the main belt group together to form the so-called asteroid families, populations of asteroids of similar makeup and of the same origin. It is thought that they formed as a result of such destructive collisions. The borders of the main asteroid belt are rather blurred. Most of the objects making it up lie within 2.06 to 3.27 astronomical units from the Sun. These boundaries are predefined by Jupiter's tidal forces and are referred to as Kirkwood gaps. Any celestial objects getting into these zones experience the massive gas giant's strong gravitational influence, which destabilizes their orbits. This is the reason why the space object count here is considerably lower than beyond. Kirkwood gaps can be found not only on the conventional borders of the belt, but inside it too. Two of the most clearly defined gaps lie 2.5 and 2.82 astronomical units away from the Sun. The asteroid belt is also conventionally divided into two large areas, inner and outer belt. The border between them is a Kirkwood gap with a radius measuring 2.5 astronomical units, which coincides with the highest orbital resonance with Jupiter. It's in the outer part of the main belt that the largest object in this area of the solar system is situated, Ceres. This celestial object used to be thought a planet, then an asteroid, but eventually, in 2006, it was given the status of a dwarf planet. It was possible to do so thanks to the fact that Ceres has a spherical shape, unlike the absolute majority of the other objects in the belt. Its diameter measures around 940 kilometers and its mass 9.4 times 10 to the power of 20 kilograms, which incidentally accounts for around a third of the overall mass of the asteroid belt. This makes Ceres approximately 6,000 times lighter than our planet. The furthest point of the dwarf planet's orbit from the Sun is 2.9 astronomical units. When Ceres is at its perihelion, the distance to our system's center measures around 2.5 astronomical units. At this point, the planetoid's surface temperature may reach 239 Kelvin or 33 degrees Celsius below zero, although its average temperature is noticeably smaller, at just 167 Kelvin or 106 degrees Celsius below zero. The celestial body is thought to be made up of a rocky core enveloped in a cryomantle around 100 kilometers thick. Water ice accounts for up to a half of the dwarf planet's volume, or 20 to 30% of its mass. The inner part of the belt harbors the largest and most massive known asteroid in the solar system, Vesta. The object's average diameter measures roughly 525 kilometers, and its mass is around 2.6 times 10 to the power of 20 kilograms, which is almost 4 times as little as that of Ceres. The asteroid's orbit is rather elongated, with its aphelion 2.57 astronomical units and its perihelion around 2.15 astronomical units away. It takes the celestial body 3.6 Earth years to complete a full orbit around the Sun. Vesta is also remarkable for being the only asteroid visible to the naked eye. It can be seen not only on account of its impressive dimensions, but also thanks to its comparatively light surface that reflects about 42% of light shed on it. Besides, the minimal distance between Vesta and the Earth isn't that great, at just 177 million kilometers or 1.18 astronomical units. It is assumed that Vesta is a fully fledged planet in terms of its inner makeup. It appears to have a metallic core made up of nickel and iron, as well as a rocky mantle. The surface temperature of the asteroid is currently fluctuating between -190 and -20 degrees Celsius, but it used to be much warmer in the past. Dark areas to be seen on the surface in the Western Hemisphere are highly likely to be basalt plains. Such terrain features may have formed as a result of volcanic activity or collision events with massive astronomical bodies. The most outstanding geological feature on the asteroid is the giant impact crater referred to as Rhea Silvia, whose diameter measures up to 500 kilometers, and its depth is around 25,000 meters. The second largest mountain in the solar system is situated at its center, towering higher than 22 kilometers. Impressively, the crater's diameter almost equals Vesta's size. It looks like the asteroid collided with a really large object at some point in the past. The collision would have produced not only the Rhea Silvia crater, but also a great number of small bits, which are now classified as the family of Vesta's numerous asteroids. The family counts over 15,000 objects, making up around 5% of all celestial bodies of the main belt known to science today. It is posited that most asteroid families came to be as a result of destructive collisions of two large celestial objects. Sometimes the debris are mutually attracted by gravity forces, which usually blend them into a new astronomical object. However, it would have lost its monolithic nature, and sometimes astronomers informally call such formations rubble piles. For example, Sylvia, one of the largest objects in the asteroid belt, seems to fall into this category of celestial bodies. Its parameters are 384 by 262 by 232 kilometers, with a mass 1.5 times 10 to the power of 19 kilograms. This makes the asteroid's average density just 20% higher than that of water. Estimates show that cavities may account for 25 to 60% of its volume. It takes Sylvia 6.5 years to complete a full orbit around the Sun. The object's orbit's furthest point from the center of the system is up to 3.7 astronomical units. In its perihelion, Sylvia gets as close to the Sun as 3.2 astronomical units. It is assumed that some bits of debris left after a collision are not attracted to other bits, but rather become satellites of the new celestial body. Sylvia is known to have two such companions: Romulus, with a diameter measuring 18 kilometers, and Remus, measuring around 7 kilometers. Their makeup hasn't been studied yet, and it is highly likely that these objects are not monolithic either. Besides, Sylvia may theoretically have smaller satellites as well, which haven't been detected yet. Pallas is another remarkable object in the asteroid belt. It was discovered back in 1802 right after Ceres, and is the second largest asteroid in the belt. The average diameter of the celestial body is around 512 kilometers, and its mass is roughly 2 times 10 to the power of 20 kilograms, which is approximately 25% less than that of Vesta. The asteroid's orbit is exceptionally elongated and tilts to the ecliptic plane at 35 degrees. That is the reason why the astronomical body is so hard to investigate with probes. As for its orbital period, it takes Pallas around 4.6 years to orbit the Sun, in the course of which the distance to the system's center changes more than 1.5 times. With its perihelion 2.1 astronomical units, its aphelion is 3.4 astronomical units away. Pallas's surface is widely pockmarked with craters, much more so than the larger Ceres or Vesta. Studies of the chemical composition of the asteroid's surface reveal that it mostly consists of silicate rocks with small amounts of iron and water. Just like Vesta, this celestial body is thought to be one of the few potential protoplanets that are still around, which means that studying it may yield important information about the formation process of the solar system. Unlike Vesta, most asteroids cannot be seen either with the naked eye or through amateur telescopes. One of these elusive objects is called Interamnia, admittedly one of the most mysterious objects of the main asteroid belt. This is an irregular-shaped asteroid with parameters 362 by 348 by 310 kilometers, and its mass accounts for roughly 1.2% of the overall mass of all objects in the belt. In spite of its relatively large size, however, Interamnia remains largely understudied. One of the difficulties thwarting scientific progress here is the asteroid's dark surface, which absorbs around 93% of light shed on it. Interamnia falls into the exceptionally rare spectral class F, which is a subclass of carbonaceous asteroids. Research of its reflection shows that the color of the celestial body's surface is even, which means that Interamnia hasn't experienced big collisions for quite a long time. Interamnia's density is not that great, at just twice that of water. The asteroid is thought to be made up of a hard rocky core enveloped in a thick layer of ice. The surface is covered with great amounts of fine dark dust. It takes Interamnia around 5 years and 4 months to complete a full orbit around the Sun. Its aphelion is on the opposite side from 4 largest objects of the main belt, and the distance from the asteroid to the Sun varies from 2.5 to 3.5 astronomical units. In theory, Interamnia's orbit crosses the trajectories of such large objects as Ceres and Pallas, but estimates show that chances of their colliding with each other are small. There are millions of objects in the main belt, from dwarf planets to tiny meteoroids the size of a cobblestone. However, distances between them measure thousands upon thousands or even millions of kilometers. That is why a spacecraft crossing the belt would be running an almost negligible risk of getting hit by any astronomical body. Still, mathematical modeling shows that around once every 10 million years, some remarkable collisions take place in this part of the solar system that produce new debris. Even though a manned mission to asteroids in the main belt will not be in the pipeline for a long while, some of the asteroids there have been studied with the help of interplanetary space probes. For example, the Dawn probe carried out observations of Ceres and Vesta in the period from 2011 to 2016. Quite recently, the space probe Lucy blasted off the surface of the Earth. Even though its main goal is the so-called Jupiter Trojans, the spacecraft will approach the object known as Donald Johansen in the main belt and take its pictures in 2025. Also, the launch of the Psyche project is scheduled for July 2022, with the largest known metallic asteroid of the main belt as its target. Within the mission, the probe is planned to reach its destination by early 2026 and remain in the asteroid belt for at least 21 months while studying the asteroid's terrain, makeup, and magnetic field. Small though they may be, asteroids are important both from the scientific and practical point of view. Some main belt objects are real treasure troves, dating back to the early stages of the solar system formation. Studying them will give us clearer insights into processes of how planets and other celestial bodies form. And in the future, asteroids will make sources of materials for space exploration. We don't know when we will be ready for this. But every new rocket launched into space brings the space era slightly closer. For biological life to originate and start evolving, a medley of a great number of factors is called for. The chief ones are liquid water, an energy source, and a certain chemical diversity. Apart from the Earth, several more places in the solar system are potential life-harboring candidates, with Mars as the most prospective one and most closely studied starting from the recent past. Still, there are chances of discovering alien life beyond its orbit too. All it takes is to have a closer look at the next closest planet to us after Mars if we look away from the Sun. Jupiter is the largest planet in the solar system. Its mass is 318 times that of the Earth. This is a gas giant made up mostly of hydrogen and helium. Apart from these, methane, ammonia, sulfur and nitrogen compounds and water ice have been detected in its atmosphere. In spite of the diversity of chemical compounds, the possibility of finding life forms on Jupiter itself is minuscule. What with the absence of any hard surface, high temperatures of the planet's inner layers and unimaginable pressure in its interior, biological creatures simply have no chances of survival. At the same time, Jupiter boasts quite a vast array of moons. 4 of the most well-known ones, Io, Callisto, Ganymede and Europa, were discovered as far back as in 1609 by Galileo Galilei. Quite close to the Moon and Mercury in size, they are on the list of the largest satellites in the solar system. It is also suggested that Jupiter accumulated substantial amounts of thermal energy due to gravitational contraction when forming. As a result, it is now giving off more of this energy than it is getting from the Sun. That is why the gas giant, with all the objects orbiting it, may be seen as a curious version of the solar system in miniature. At first glance, Jupiter's moons may appear to have no prospects in terms of searching for extraterrestrial life. Far from the Sun, they are encased in ice, and their atmospheres are not dense. However, on closer scrutiny, these celestial objects reveal something excitingly promising. Callisto, Europa and Ganymede are highly likely to have liquid oceans under the ice shell. estimates show that space objects with concealed oceans may offer favorable conditions for life even if they are much further from their star than planets like our Earth are from the Sun. The thick icy shell on their surface serves not only as protection against radiation and meteorite infall, but also acts as fairly good thermal isolation. That is why it is feasible that conditions inside a massive layer of water may be good enough for life to originate and evolve there. These assumptions make Jupiter's satellites some of the most attractive objects for exploration within the solar system. And now let's have a closer look at each of them. Ganymede is the largest and most massive celestial object in Jupiter's environs. Of all the satellites in the solar system, it is not only the one sporting the most impressive dimensions, but it also resembles a real planet more than any other. Ganymede's radius measures 2,634 kilometers, which is 8% more than that of Mercury. As for its mass, it equals 1.48 times 10 to the power of 23 kilograms. This is twice the mass of our Moon. Interestingly, Ganymede is the only satellite in our solar system with a liquid metal core and its own magnetosphere. Processes of nuclear decay take place in Ganymede's interior. This heats the satellite still more, with the average surface temperature 110 Kelvin or 163 degrees Celsius below zero. The core, on the other hand, is estimated to be as hot as up to 1,500–700 Kelvin. Investigations of Ganymede's magnetic field, carried out by the Galileo space probe, showed that there may be a multi-layer salty ocean under the satellite's icy shell as deep down as 200 kilometers or more. The number of layers may reach 4. Water in each is of different salinity, density and temperature, with the layers separated from each other by some ice. Spectrographic investigations of Ganymede's surface show it to have a rather rarefied oxygen atmosphere. This, however, isn't an irrefutable proof of there being biological life on the satellite. Molecular oxygen is likely to form as a result of the exposure of water ice to ultraviolet radiation. Hydrogen, the other product of this chemical reaction, floats away into space. Oxygen, meanwhile, which is a heavier element, settles close to the surface. Apart from large amounts of water ice, other elements found on Ganymede's surface are carbon dioxide, sulfur dioxide, sulfates and some other organic substances. They may well have originated in the depths of the subsurface ocean, but the mechanisms of their settling on the satellite's surface are still not clear. Callisto is another celestial object potentially just as attractive for life. This satellite is Jupiter's second largest one and lies furthest from it. Its diameter measures 4,820 kilometers, almost like that of Mercury. Callisto is encased in an icy shell as thick as 80 to 150 kilometers, and it is highly likely that there is a salty ocean concealed under it containing large amounts of ammonia and other substances. The estimates of its depth range from 50 to 300 kilometers, and its temperature is around 251 Kelvin or 21 degrees Celsius below zero according to most models. Due to impurities and high pressure, the water in the ocean should remain in its liquid state. Below the subsurface ocean there is bound to be a layer of ice as thick as around 300 kilometers, and the satellite's core, made up of water ice and rocks, lies still deeper down. Callisto's surface is pockmarked with craters. Spectral analysis of light reflected from this celestial object revealed not only water vapor and silicon rocks, but also ammonia, carbon dioxide, sulfur, iron and magnesium compounds, as well as tholins, complex organic polymers containing nitrogen. These brightly colored substances form on the surfaces of celestial bodies, a result produced by ultraviolet radiation. Callisto happens to lie too far from Jupiter to get more heat from it. Besides, the tidal influence exerted by the giant neighbor isn't enough to deform the satellite, although friction in the process would heat it up. Also, most of this body is made up of ice, whereas it is preferable that there should be solid rocks, which would saturate water with elements vital for life forms to originate. With the diversity of chemical compounds here rather modest and the temperature quite low, it hardly improves chances of life evolving here. Still, this possibility should of course not be ruled out yet. The most promising of Jupiter's satellites in terms of searching for alien life is Europa. The smallest of Jupiter's 4 Galilean moons, it is just a bit smaller than our moon. The equatorial temperature on this celestial body is 110 Kelvin or 163 degrees Celsius below zero. At the poles, temperatures may drop to 50 Kelvin or 223 degrees Celsius below zero. Europa is tidally locked to Jupiter, facing it with the same side only. However, its rotation isn't synchronized ideally. There are deviations from the calculated trajectory. This may mean that there is a liquid layer between Europa's surface and core. This assumption is confirmed by observation of interaction between the satellite and Jupiter's magnetic field carried out by the Galileo space probe in the late 20th century. Apart from that, analysis of crevices Europa's surface is covered with shows that the satellite's crust moved 80 degrees with respect to the interior. This would have been impossible without a liquid layer between them. The massive neighbor exerts a strong influence over Europa by causing powerful tidal waves in its subsurface ocean. This way, the satellite is heated still more by internal friction. Estimates show that the temperature in Europa's interior is high enough for an ocean of water to be in liquid state. Its depth may reach 100 kilometers, and its volume may be twice that of the global ocean on our Earth. Europa is covered with an even layer of exceptionally smooth and clear ice. The highest elements of relief tower just several hundred meters above the surface. The thickness of the icy crust may be anything from 10 to 30 kilometers, although the satellite's surface is streaked with a whole net of long and deep cracks. Some of them may well reach as deep as the subsurface layer of water. Thus, the ice at the bottom of these ravines is valuable material for studying the inner makeup of Europa. Another peculiar feature of this moon is powerful ice-cold vapor geysers. They open up only when Europa is at its furthest point from Jupiter, with the height of the spurts reaching as much as 200 kilometers. These giant jets are made up of water vapor, which incidentally is unexpectedly clean. It is still not known for certain whether the geysers have anything to do with the ocean in Europa's interior, or they come from gargantuan lakes embedded in the satellite's icy crust. Today, the composition of the subsurface ocean on the satellite is estimated by analyzing the ice covering the inner part of its largest craters. Only a really large object is capable of breaking the thick layer of the ice clean through on impact. After the icy crust is broken, the water in the subsurface ocean at the impact site freezes and forms the bottom of a crater. Spectral analysis of the craters reveals magnesium, sulfur and iron compounds, as well as hydrogen peroxide and strong acids. This demonstrates that there is a vast diversity of minerals in the satellite's concealed hydrosphere. Europa's atmosphere contains oxygen, which forms as a result of ultraviolet radiation interacting with the ice water on the surface, splitting the water into oxygen and hydrogen. The satellite's atmosphere, however, is approximately 1 trillion times as rarefied as that of our Earth. Still, according to some estimates, concentration of oxygen in Europa's subsurface ocean should be sufficient for supporting single-cell aerobic life forms. Underwater volcanoes should be their sources of energy and food, as they saturate water with sulfur and iron oxides. Primitive organisms may attach themselves to the bottom side of the ice crust or swim freely in water. It was even assumed that there may dwell primitive multicellular organisms in Europa's ocean. However, this hypothesis appears to be rather too presumptuous. In fact, there is a great many species on our Earth which would be able to survive in the estimated conditions of Europa's subsurface ocean. There are among them not only bacteria resistant to harsh environments, but multicellular creatures too. for example tardigrades. Consequently, we cannot rule out the possibility of primitive life originating in the depths of this celestial object of its own accord. Unfortunately enough, in spite of the keen interest we have in Jupiter and its satellites, so far they have been investigated only briefly, and that by spacecraft passing them on their way elsewhere. No landings on the gas giant's satellites have so far been attempted. At the moment, the largest planet in our system is being investigated by the Juno probe, but as soon as in July 2021, it will move on to studying the Galilean moons. The data collected by Juno will undoubtedly be of great importance and help get to the bottom of processes taking place in Jupiter's system. As for upcoming missions, back in 2012, the European Space Agency announced starting work on the JUICE project, or Jupiter Icy Moon Explorer. The mission of the project is to explore in detail the gas giant itself, as well as Ganymede, Europa and Callisto. JUICE will be launched next year, but will reach Jupiter's environs only in 2029. The mission is scheduled until the year 2033. If all goes according to plan, our knowledge about the gas giant and its satellites will be substantially expanded. Another big research project is NASA's Europa Clipper. This automatic probe is planned to lift off the Earth's surface not later than 2023 and to reach Jupiter's system in 2032. The probe's objective is quite predictably Europa. In contrast to JUICE, it is this celestial body that Clipper is supposed to focus on more closely. Approximately 100 million years ago, a large icy satellite approached Saturn too closely. The gas giant's extremely powerful tidal forces shattered it into trillions of small bits. Obeying the overwhelming physical laws, these bits gradually spread out, embracing the planet in a primary ring. It was roughly 1,000 times more massive than Saturn's today's rings. Millions of years have passed since the time of the disaster. Since then, some part of the destroyed satellite's fragments was swallowed up by Saturn without a trace. Other debris bombarded the surfaces of its multiple satellites, or else left the environs of the gas giant altogether. This is one of the most well-grounded scientific hypotheses today that account for the origins and evolution of Saturn's rings. Even after hundreds of years of observations, this tremendous structure in space still hides a lot of secrets. Saturn's rings do not have a clear-cut border. The width of their visible part is about as much as 280,000 kilometers, although there are thinnest clusters of dust and rarefied gas beyond these borders. These structures' diameter reaches 16 million kilometers, according to some estimates, although they cannot be seen from the Earth on account of their extremely low density. In spite of the impressive dimensions, the total mass of the ring system is quite small by space standards and is estimated at 3 × 10⁻⁹ kilograms. which is about 2,000 times lighter than the Moon. Solid objects account for only 3% or so of the structure's overall volume, with the rest filled with rarefied gas and cosmic dust. The disk surrounding Saturn is conventionally divided into several large rings. However, a rather powerful optical telescope will reveal each of them to be clearly made up of a large number of thin circles separated by narrow gaps. These gaps form due to the gravitational influence of both the planet itself and its many satellites. Some of them are as much as several hundred kilometers wide. Even though Saturn's disk reflects several times more sunlight than the gas giant itself, some rings are next to impossible to see. For example, the D ring, the closest to the planet, which consists of tiniest water ice crystals and frozen methane. Its upper border is posited to be located 16,500 kilometers above the planet's conventional surface. As for its inner part, the ring has no clear-cut border and gradually fuses with Saturn's atmosphere. Next to it is the brighter and more massive C ring, which is approximately 17,500 kilometers wide. It is comprised of space objects measuring up to 2 meters and which make up just 0.033% of the disk's overall mass. The brightest and most outstanding part of the disk is located further and is designated the B ring. It begins roughly 34,000 kilometers above the surface of the gas giant, and its width reaches 25,000 kilometers. The thickness of the larger part of the ring does not measure over 5 to 10 meters, while its outer part forms a vertical rim towering up to 2.5 kilometers high. The outermost visible ring of Saturn begins 64,000 kilometers above the planet's surface. It is roughly 14,600 kilometers wide, harboring not only comparatively large ice bits of 10 meters and more, but some satellites as well, such as Pan, Daphnis and others. The existence of such large objects may prove the theory of ring formation following the destruction of the ice satellite. Alternatively, they may have formed at a later time as a result of smaller fragments colliding and merging. Beyond this part of the disk, there lie the almost unobservable F, G and D rings, which formed from cosmic dust and rarefied gas. It goes without saying that most of Saturn's large satellites actively interact with the rings. Traveling as far as 179,000 kilometers away to the region of the so-called E ring, the celestial body dubbed Enceladus is to be found. With a diameter measuring just 500 kilometers, it does not qualify as one of the gas giant's largest satellites, but it stands out for other reasons. The point is that Enceladus is one of the few celestial bodies in our system where there are clear manifestations of cryovolcanic activity. Analysis of the observed emissions proves that there is an ocean of liquid water under its surface. Mathematical modeling shows that its temperature measures from 45 degrees Celsius below zero in the upper layers to 0 degrees at the bottom. Due to a high content of dissolved salts and ammonia, the ocean does not freeze over even in sub-zero temperatures, with the icy shield about 2 kilometers thick covering and thermally insulating it. The celestial body's surface temperature is about 75 Kelvin or 198 degrees Celsius below zero. Its atmosphere is extremely rarefied and is 91% water vapor. Other elements making it up are nitrogen, carbon dioxide and methane. Powerful geysers that erupt from time to time through cracks in the icy crust of the satellite regularly supply its atmosphere with chemical elements, but the celestial body's weak gravity is not enough to prevent the atmosphere from floating away. The upper region of the atmosphere is constantly losing some amount of particles that go to sustain the E ring. On the other hand, Enceladus constantly captures material from the space around it, thus ensuring its peculiar chemical balance. It is known that geyser activity of this celestial object depends on its orbital movement. It is likely that Saturn's tidal forces deform the satellite's icy shield, causing it to crack in multiple places and to erupt. It is also known that the cryogease's emissions contain elaborate organic molecules, which may mean that the conditions in the subsurface ocean may hypothetically be favorable for the genesis of biological life. Also, the gas giant's fifth largest and most massive satellite, Tethys, can be seen approximately 300,000 kilometers away from it. It is peculiar for sharing the same orbit with two other celestial objects, Telesto and Calypso. They are located at the so-called stable Lagrange points, with Telesto 60 degrees ahead of the main satellite in its movement along the orbit, while Calypso, on the contrary, lags 60 degrees behind. Unlike the massive spherical Tethys, these celestial bodies are not that large and are irregular in shape. They measure roughly 20 to 30 kilometers in diameter, with their overall mass just several trillion tons, which is modest by space standards. Interestingly, modeling shows that Calypso and Telesto could not have originally formed in the same orbit with a more massive body following it, which means that they arrived to join it at a much later time. As for Tethys, it is a celestial object with a diameter measuring about 1,060 kilometers, made up of mostly water ice, with some rocky impurities in its composition. The most outstanding feature of its relief is the giant impact crater Odysseus. Its diameter measures around 450 kilometers, which is about twice as small as the diameter of Tethys itself. Its depth reaches as far down as 3 kilometers. There is also an easily noticeable chasm of enormous proportions on the satellite's surface, which is called the Ithaca Chasma. It is as long as about 2,000 kilometers. That is about a third of the celestial body's circumference, and as much as 100 kilometers wide. As for its depth, it ranges from 3,000 to 5,000 meters, and the bottom is pockmarked with a great number of craters and minor irregularities of the surface. According to one of the theories about it, the Ithaca chasm formed as a result of Tethys's subsurface ocean freezing over. On turning into ice, the water expanded in size and erupted through the satellite's outer crust. Another assumption about the chasm has to do with the Odysseus crater. It is thought that the impact waves traveled across the entire surface of the satellite and caused a powerful resonance around its circumference. As a result, Tethys's crust cracked, forming this incredibly large chasm. Still further from Saturn, there lies its largest satellite, Titan, which also boasts quite a number of highly unusual features. With a diameter measuring 5,152 kilometers, it is in fact the second largest satellite in the solar system, with Ganymede holding the first place. It is also remarkable for being 5.5% bigger than Mercury. Titan is also the only satellite in the solar system with a dense atmosphere and bodies of liquid on its surface. Since Titan lies quite far from the Sun, the temperature of this celestial body is quite low at around 94 Kelvin or 180 degrees Celsius below zero. Having said that, in spite of its comparatively small mass, Titan is capable of sustaining an atmosphere which is 1.5 times denser than that of the Earth. Nitrogen accounts for over 98% of the atmosphere's chemical composition, with methane and other gases making up the rest. Exposed to solar wind, nitrogen and hydrocarbon compounds in the atmosphere's upper layers transform into more complex organic substances, which subsequently slowly settle on Titan's surface. Due to the impermeable hydrocarbon smog, the satellite's surface is unobservable in the optical range. According to the most plausible model of Titan's inner structure, there is a massive rocky core at its center, with a diameter measuring about 3,400 kilometers. It is embedded in a thick layer of exceptionally dense ice, which forms the bottom of a cool salty ocean containing up to 10% of dissolved ammonia. It is buried under a crust of water ice mixed with methane hydrate, which is many kilometers thick. In temperatures as low as that, the ice has properties identical to those of a solid substance and forms mountain ridges and elevations on the surface. As for lowlands and chasms, they are filled with lakes of liquid ethane and other hydrocarbons. Solar wind and Saturn's extremely powerful magnetic field constantly strip Titan of its atmosphere. However, its internal processes keep replenishing it, so the process of losing it may take billions upon billions of years. When the Sun hits the red giant phase, it will be capable of vaporizing the hydrocarbon haze and melt the eternal ices on Titan. After this, the satellite will become a more favorable place for the genesis of life. However, it will not happen for a while yet. Of course, Saturn's system does not end there. Pluto is about 40 astronomical units away from the Sun and is a dark and indistinguishable object. This distant celestial body follows a rather elongated orbit around the center of the solar system, completing it every 248 Earth years. We know that Pluto's radius is 1,188 kilometers, which means that it is noticeably inferior in size not only to all the planets of the solar system, but also to some of their satellites, including the Moon. At the same time, observations of the celestial body's proper motion made it possible to calculate its mass with a high degree of accuracy. It turned out to be small, only 1.3 times 10 to the power of 22 kilograms, or 18% of the lunar mass. It is easy to see that Pluto is much more similar to small celestial bodies such as Eris, Ceres or Sedna in terms of its characteristics. This is the reason why it topped the list of dwarf planets in 2006. Due to its long and elongated trajectory, Pluto has a long orbital cycle. Only in 1989 did the planetoid first pass its orbit perihelion since its discovery, approaching the Sun as close as 29.7 astronomical units. Since then, this distance has been continuously increasing and will reach its greatest value in the year 2113. By that time, the dwarf planet will be near its aphelion, which is 49.3 astronomical units away from the center of our system. Thus, Pluto is a very distant and dim space object. That is the reason why it cannot be seen from Earth with the naked eye. And even in images from the Hubble Space Telescope, the dwarf planet looks like a murky brown disk without any surface details. Of course, in such conditions, it is almost impossible to study the celestial body properly. To solve this problem, the New Horizons Unmanned Orbital Station was sent to Pluto in 2006. It took a long 9.5 years to reach its destination. On its way, it beamed back to us detailed images of Jupiter. It wasn't until 2015 that the spacecraft finally reached the main object of its mission. As it flew past Pluto, the station made about 400 observations, collecting more than 6 gigabytes of information, and it took more than a year to transmit this large amount of data to Earth. Unfortunately, the probe's trajectory did not allow photographing the entire surface of the dwarf planet. The fact is that New Horizons did not enter into an orbit around Pluto, but circled round Pluto in order to be able to explore other space objects. Before moving on to the celestial body's terrain features, we need to understand its internal structure. According to the currently accepted model, Pluto has a massive core with a diameter of about 1,700 kilometers, consisting of a mixture of various forms of water ice and rocks in its center. It is surrounded by a 300-kilometer ice mantle. There are probably tectonic processes running in the mantle, and in the moment they are quite understudied. The mantle, in its turn, is covered by a crust, which is a mixture of crystallized gases such as nitrogen, methane and carbon monoxide. According to some assumptions, Pluto's core may generate enough heat to melt some of the icy mantle. In this case, deep beneath the surface of the planetoid, there should hide a very salty and toxic ocean containing large amounts of dissolved ammonia. As for the surface temperature of the dwarf planet, it is very low and is not over 60 Kelvin or 213 degrees Celsius below zero. Our journey around Pluto we'll start at the most outstanding and well-studied feature of its relief, Tombaugh Regio. This vast area is located in the equatorial zone of the planetoid and is shaped like a heart sketch. This resemblance earned the region its informal nickname, the Heart. Its size reaches 2,300 kilometers, which means that the plane occupies about a quarter of the celestial body's entire area. Tombaugh Regio's surface is not homogeneous. Thus, there is a smooth and light plane in its western part, known as Sputnik Planitia, whose diameter measures 1,492 kilometers. An elevation map will reveal this region to be a vast lowland area. It is covered with a thick layer of nitrogen ice, as well as carbon monoxide and solid methane. These substances have a light coloring, which makes some parts of the plane reflect up to 90% of the light falling on them. There are also virtually no craters, which means that the region is very young in geological terms. According to the main hypothesis, Sputnik Planitia formed about 100 million years ago, when Pluto experienced a collision with a large celestial body. As a result, a huge impact crater appeared. It was filled with contents of the hypothetical inner ocean of the dwarf planet, which rapidly froze there. Some typical features of the relief of the plane can serve as evidence of this. For example, there are quite a number of smooth surface areas on it, ranging from 20 to 30 kilometers in size, with hills and depressions concentrated on the borders between them. This kind of structure resembles convection cells, which appear in any fluid heated from below. This may serve as an indirect confirmation of the hypothesis of Pluto's warm interior. Tombaugh Regio is surrounded by comparatively high mountain ridges. Thus, Hillary Montes, lying to the west from Sputnik Planitia, reach 3.5 kilometers in height. Tenzing Montes are located in the southern part of the heart. Some of them tower as high as over 6 kilometers above the dwarf planet's average surface level, which makes this ridge the tallest one found on Pluto. Remarkably, these rocks are likely to be made up mostly of water ice. And in temperatures as low as here on Pluto, water ice is as solid as rock. Moving a little further south, we can see a deep basin surrounded by massive multi-layered ridges of ice and rock. It is assumed that it may be the vent of an ancient cryovolcano, and the rock around it is its numerous frozen eruptions. Their chemical composition is of great interest to science, because once it is known, the peculiarities of Pluto's inner makeup may be studied. The eastern part of Tombaugh Regio is darker. In addition, its surface is pockmarked with a great number of craters, which means that this region is by far older than Sputnik Planitia. Moving further east along the equator, we will see a chain of dark spots, hundreds of kilometers in diameter. These objects are called maculas and are named after dark deities of various cultures. For example, one of them is named Balrog. Together they form a giant structure called the brass knuckles, encompassing the celestial body along the equator. The maculas are separated by high mountain ranges, and their surface is cut by deep crevices reaching hundreds of kilometers in length. Cthulhu Macula stretches to the west from Tombaugh Regio. It is the largest dark spot on Pluto, measuring almost 3,000 kilometers. Its surface reflects not more than 30% of the light shed on it, which is a stark contrast with the bright and light Sputnik Planitia close by. There is still no reliable information about what maculas are. It is assumed that their dark color is due to a high content of tholins, combined with a relatively large concentration of impact craters. This indicates that maculas are remarkably old. It is also known that the surface of Cthulhu Macula is heterogeneous. Thus, its relief in the western part is undulating. The central part is a smooth plain, and the eastern part is covered with mountains and craters. Leaving the grim spot of Cthulhu Macula behind us, let's head north. Here lies Lowell Regio, the vast valley surrounding Pluto's North Pole. Surprisingly, it is this place that is currently the most illuminated part of the celestial body's surface. The point is that Pluto's axis of rotation has a very large tilt with respect to the plane of its orbit, so in its movement it found itself facing the Sun with its north pole. It is assumed that it's for this reason that the density of Pluto's atmosphere has tripled over the past 30 years, despite the growing distance from the Sun. It is likely that the Sun's rays evaporate nitrogen ice settled at the pole, which goes into the dwarf planet's atmosphere. In its orbital motion, Pluto has a number of peculiarities compared to the planets of the solar system. In addition to the fact that its orbit has a noticeable tilt to the ecliptic plane, the planetoid itself constantly performs cyclic oscillations near a certain point. This is due to the presence of a large satellite, gravitationally affecting the dwarf planet. It is called Charon, and its mass is 1.52 times 10 to the power of 21 kilograms, which is more than 11% the mass of Pluto itself. As a consequence, both celestial bodies orbit a common mass center between them. They are tidally locked to each other, so they face each other with the same sides at all times. Unlike Pluto's, the surface of its satellite is noticeably darker and shows an abundance of water ice, which is mixed with methane and nitrogen only in some regions. In addition to Charon, there are several other satellites, but all of them are much smaller and are irregular in shape. Nix and Hydra, discovered in 2005, measure several tens of kilometers, and Kerberos and Styx, which were discovered later, are not over 16 kilometers in diameter. All of these celestial bodies consist mainly of water ice and were probably captured by Pluto's gravity from the Kuiper belt. Unfortunately, a significant part of Charon was not caught in the field of view of the New Horizons probe's cameras, but many curious terrain features can be found on the visible surface of the celestial body. For example, to the south of the equator, there lies a vast region called Vulcan Planum. Its area is not known precisely, but it is not less than 400,000 square kilometers, which is comparable with the size of an average European country. Here, the highest summit of Charon can be found, Kubrick Mons. Its diameter measures around 40 kilometers, and according to some estimates, its height reaches 4,000 meters. In addition, the mountain is surrounded by a wide circular moat, as it were, up to 2 kilometers deep. According to some assumptions, Kubrick Mons may in fact be a cryovolcano. In this case, it is very likely that the area around it has sunk under its own weight due to the emptying of the underground reservoir. To the north stretches the vast Oz Terra, the surface of which is pockmarked with many craters. It is separated from Vulcan Planum by a system of giant ledges and crevices with a total height of about a kilometer. The largest of them is Serenity Chasma, which is 200 kilometers long with a width varying from 40 to 50 kilometers. It can be as deep as 7 kilometers, and it is difficult to explore its bottom because of the thick shadows cast by the steep slopes. Further north yet, near the very pole, there is the giant Mordor macula. Its diameter reaches 475 kilometers, and its origin is still debatable. According to the dominant hypothesis today, nitrogen and methane floating from Pluto's atmosphere were trapped by Charon's gravity and so settled at its poles. After exposure to ultraviolet radiation, they turned into tholins and gradually concentrated in the ice of the celestial body. This assumption needs verification, which will be an object of future missions. Charon largely remains a mystery to us because its research is only just starting. Although the Pluto-Charon system is undoubtedly one of the most interesting structures in the solar system, it is still understudied. Unfortunately, the New Horizons probe left its environs long ago, and the celestial bodies themselves are rapidly moving away from us, taking their secrets along. At the moment, the probe is more than 50 astronomical units away from the Earth, and from time to time beams back to us some extremely important data. By about 2030, all of its systems will eventually fail, and the probe will be left all alone in the chilling recesses of space. Roughly half a year before this video was posted, on the 15th of April 2021, the automatic space probe New Horizons became the 5th spacecraft in the history of the humanity to go beyond the point of 50 astronomical units from the Sun. It was the Voyagers that had crossed this mark before, with the probes Pioneer 10 and Pioneer 11 the first ever to do so. None of these space wanderers are likely to ever return to the Earth. With some of them still active on their missions, others have gone quiet forever. Spacecraft New Horizons. Start of mission 19th of January 2006. Distance to Earth 52 astronomical units. Speed 14 km per second or 3 astronomical units per year. Main goal Pluto and Charon. Mission status successfully completed. Condition operational. Just like most other interplanetary space probes, New Horizons performed a gravity assist maneuver near Jupiter before setting out to its target. Not only did it greatly boost the spacecraft's speed, but also allowed it to capture high-quality images of the largest planet in the solar system alongside its satellites. Besides, the probe's cameras captured the first video ever of an erupting volcano on the surface of Jupiter's satellite Io. After the gravity boost had been completed, the probe made for the main target, Pluto. The spacecraft reached the planetoid's environs in January 2015. The mission's main goal was to explore Pluto and Charon from different perspectives that involved taking photos of and mapping these remote space object surfaces. In addition, the probe estimated the magnetic field's values and the solar wind activity close to the objects and collected information about their atmospheres and surface reflection properties. It goes without saying that the program also involved search for Pluto's as yet undetected satellites and more accurate measurements of Pluto's orbit's parameters. Having completed the main mission, the probe continued to be useful. It flew beyond Pluto's orbit and went on to explore objects in the Kuiper Belt. That is how images of Quaoar, R1 and Arrokoth were produced. Thanks to the probe's cameras, the distances to the stars Proxima Centauri and Wolf 359 were measured. Unfortunately, the radioisotope generator on board the spacecraft is expected to start running low from 2026, and eventually all the meters will switch off one after another. New Horizons will continue on its way beyond the boundaries of the solar system, and by the year 2038, the distance between the probe and the Sun will have grown to be 100 astronomical units. By that time, the energy generator on board the spacecraft will have stopped operating completely, and it will be impossible to get any connection with it. Following a hyperbolic orbit, New Horizons will exit our system, never to come back. The same thing happened with two other probes, Pioneer 10 and Pioneer 11. They hit an escape trajectory from the solar system a while ago. In fact, they were the first automatic space probes ever to be sent into interstellar space by humans. Spacecraft Pioneer 10. Start of mission 3rd of March 1972. Distance to Earth 127 astronomical units. Speed approximately 12 km per second or 2.5 astronomical units per year. Main goal Jupiter. Mission status successfully completed. Condition not operational. The spacecraft reached Jupiter's system on the 4th of December 1973 after completing a 641-day journey through space. During the mission, images of the gas giant's surface and its largest satellites were beamed back to the Earth, and the planet's atmospheric composition and magnetic field were gauged. In addition, Jupiter was found to emit 2.5 times more thermal energy than it receives from the Sun. The data, unique at the time, became the basis for understanding the makeup of gas giants and their satellites. The trajectory of the second probe, Pioneer 11, through space passed Jupiter too, but its main target was the other gas giant of our system, Saturn. The probe's scientific instruments gauged the planet's magnetic field, and the cameras on board took quite a few snapshots not only of the gas giant itself and its system of rings, but also 2 of its satellites, Titan and Mimas. According to the estimates, the current distance between Pioneer 11 and the center of our system is around 106 astronomical units. On completing their main mission, both probes continued on their way, moving further and further away from the Sun. Unfortunately, both of them are out of range now, with the last signal from Pioneer 10 received back in 2003. The last signal from Pioneer 11 was received in 1995. Supposedly, both of them are now rapidly moving beyond the boundaries of the solar system. Incidentally, having no chance of ever catching up with either of the 2 probes we're going to talk about next, the Pioneers were launched at a much earlier date. Spacecraft Voyager 1. Start of mission 5th of September 1977. Distance to Earth 154 astronomical units. Speed around 17 km per second or 3.6 astronomical units per year. Main goal: Jupiter and Saturn. Mission status: successfully completed. Condition: not fully operational. The contribution of Voyager 1 to the solar system's exploration can hardly be overestimated. It is thanks to this probe that several new Jupiter satellites were discovered, alongside its ring system, which was big news. The Voyager's cameras captured volcano eruptions on Io and provided hard evidence that Jupiter's Great Red Spot is an enormous storm. The probe beamed back hundreds of photos of the largest planet of our solar system and its satellites. After the spacecraft crossed Neptune's orbit, the meters on board sent back a great amount of valuable data about interstellar plasma. Voyager 1 left both the Kuiper Belt and the heliopause behind a long while ago, and is now rapidly crossing the area of the solar system's scattered disk, making for the inner boundary of the hypothetical Oort cloud. It is not only the remotest man-made object in space, but also the fastest of all the spacecraft on their way to exit our system. Being the first space probe to have traveled that far from the center of the solar system, Voyager 1 offered scientists a unique opportunity to study the heliopause. This is the area around our Sun where solar wind pressure and interstellar gas pressure balance. When the charged particles emitted by the star collide with rarefied plasma, elaborate structures form out of elementary particles and magnetic fields. Studying them is crucial for understanding processes taking place in the universe. Unfortunately, by around the year 2025, the power of the radioisotope thermoelectric generators on board the probe will have run out completely, and the connection will have been lost. In 300 years, Voyager 1 is estimated to reach the inner boundary of the hypothetical Oort cloud. It will take the spacecraft approximately 30,000 years to go clean through, and after that it will fly beyond the boundaries of the solar system. 10,000 years later still, the probe will fly by the star Gliese 445 at a distance of 1.6 light-years, and then it will eventually get lost in the infinite depths of outer space. Speaking about Voyager 1, we can't but mention its twin, launched from the Earth on the 20th of August 1977. Voyager 2 had Saturn, Uranus and Neptune for its targets, but it also approached Jupiter for a gravity boost. It's the images taken by this probe that allowed scientists to assume that there are subsurface oceans on Ganymede and Europa. On reaching Saturn, Voyager 2 gauged the gas giant's temperature and magnetic field and discovered several new satellites. It goes without saying that lots of snapshots were taken of both Saturn's surface and its rings. Next in line on the probe's way were Uranus and Neptune. The flyby yielded a great number of unique snapshots, and in total 17 of the 2 planets' satellites were discovered. Also, it was found that both Uranus and Neptune have ring systems. Under Neptune's gravitational influence, the spacecraft changed its trajectory and left the ecliptic plane. This meant that Voyager 2 wouldn't be able to approach the other objects in the solar system, but it still had other exciting things to look forward to. Thus, the probe was to collect invaluable data about interstellar plasma and cosmic wind, as well as to measure distances to stars and explore the heliosphere. The probe is currently as far as 128 astronomical units away from the center of our system, with the distance growing by 15.37 kilometers every second. It's going to take it around 42,000 years to approach Ross 248, a dim red dwarf in the constellation Andromeda. The minimal distance between Voyager 2 and the star will be about 1.7 light-years, and around 300,000 years since its launch, chances are it will fly by Sirius at a distance of 4.3 light-years. Unfortunately, it is impossible to distinguish such a tiny object from the Earth that far away. We live at the dawn of space exploration, and interplanetary space probes are just mankind's first timid steps in exploring the infinite universe. It is hard to predict their fate. They may be smashed on collision with a celestial body, or they may be recaptured by our distant descendants, who will have advanced interstellar travel technologies to the point of being able to catch up with the probes. For all we know, they might recover them from space and put on display in a museum. But it is more likely that the fragile apparatuses are destined to drift on for years and years through the lifeless expanses, and millions of years later, radioactive rays and rare particles of cosmic dust whizzing through the probes time and time again will eventually wear them down to threadbare debris, to be scattered across the depths of the universe without a trace. There are at least 200 billion stars in our galaxy at the very least. Some of them have no planetary systems, while others could challenge our Sun in terms of diversity of the bodies orbiting them. The depths of the Milky Way are home to not less than 1 trillion planets, most of which are still waiting for their discoveries. And this means that our journey is only just starting, and your support is a potent motivational factor for it to continue and bring us to the remotest worlds.